Are you a beginner and want to learn Houdini? Then I welcome you to Nexttut Education's Houdini for Absolute Beginners course. Hi, my name is Shehzad and I will be your instructor throughout this course. In this course, we will learn Houdini from the ground up. First, we will talk about the geometry basics and talk about the geometry grouping and the geometry attributes and scattering and aligning the geometry. And here we will create two procedural projects. First we will create a procedural staircase and we'll turn this into a Houdini digital asset, and we will create a Houdini fully procedural nuclear cooling tower. And after that we will dive into vex and warps, and we will talk about how to manipulate geometry and manipulate attribute with vex and warps. In here we will talk about how to write vex code, and we will create a projection deformer both in warps and in vex. And after that we will dive into volumes, and in here we will talk about the voxels and create clouds with the fog volume. And after that we will dive into tops, and in here we will set up the smoke simulation, how to set up the smoke solver and create a smoke simulation. And after that we will talk about the pyro solver and create a fire simulation and create the sparks for our fire. And we will render this in aces, and we will talk about how to set up the aces colors. And after that we will talk about the explosions and create an explosion project. And after that we will dive into the particles and talk about the particle forces, how to manipulate particle with the forces. And we will talk about the particles advection, how to advect particles with the smoke simulation velocities, and how to disintegrate geometry with particles. And after that we will dive into the pop grains to create the granular simulations like sand. And in here we will talk about how to activate the grains, and we will talk about grain soft bodies, how to transfer grains soft body simulation into geometry. And after that we will talk about the rigid body dynamics, how to set up the rigid body dynamics solver. And in here we will take a look at the different geometry fracturing technique, and we will talk about the RBD activation, and we will talk about the rigid body constraints. And after that we will talk about the vellum to create the soft body simulations with vellum. In here we will talk about the vellum pressure constraint, vellum shape and vellum hair, and how to tear a cloth with vellum. And we will finish this course off with flip fluids. In here we will talk about how to set up basic flip fluid simulation, and we'll talk about the flip viscosity to create viscous fluids. We got a lot to cover, so join me and let's get started. Okay guys, so here are the project files of the course that you can download, and here we have the project files for each chapter. And don't forget to rate the course and write the reviews, and I'll see you in the next lesson. Okay, so here we are in Houdini. This is how the Houdini user interface looks like when you first open it up. So right here we have the scene view, up here we have the shelf, and here we have the parameter window, and down here we have the network editor, and at the bottom we have the play bar to play back our animation or simulation. So you can navigate in the scene around by press and hold the left mouse button and move your mouse to rotate, press and hold the middle mouse button to pan, press and hold the right mouse button to zoom in and out. So let's create something in our scene. Go into the shelf and click on the box. So now the red box is highlighted. So just click anywhere in the scene view where you want to place the box. So now the box is created. Okay, so when we create the box, our tool is switches to these manipulator, so we can place our box in the scene. So now if you want to navigate in the scene, just press and hold the Alt key on your keyboard. So pressing and holding the Alt key will temporarily switch you to the camera view tool. So now using the left, middle and right mouse button, I can navigate in the scene. So the short key for the view tool is the escape key. So just press the escape key on your keyboard. Now it will switch you to the camera view. Okay. So we can move the box by coming here where we have the tools. So just click on the move tool. The short key for the move tool is the T. So now I can use these handles to move my box. And here we have the rotate tool and the short key is the R. So now I can rotate my box. And down here we have the scale tool and the short key for the scale is the E. So by using the scale tool, I can scale my box. Okay. So now select the camera view tool to navigate in the scene. You can also navigate in the scene by the first person navigation style. So when you are in the camera view tool, so here we have some options. So if you want to switch to the first person navigation style, just click on this drone icon. Now I can use the W key, A, S and D to navigate in the scene. Now the speed of the movement is very slow. So you can change the speed by click on this gear icon and where it says movement speed. Let's change this to 5 and let's try that again. Press and hold the W key. Now I am moving A, S and D. Okay, so if the movement speed is still slow, just click on the gear icon again and let's change this to 10. Okay, now you see our movement speed is increased. You can disable the first person navigation by clicking on this drone icon again to disable the first person navigation. Okay, you can access your quad view by pressing the B key on your keyboard. This will switch you to the quad view. So now we have the access to the top, front and the right view. So if you want to maximize the top or the right or front view, just hover over to that view and press the B key to maximize that view and press the B key again to bring up our quad view. So let me come into the perspective. I'm hovering over onto the perspective view and press the B key to maximize our perspective view. You can also change your quad views from here where it says perspective. Just click on that and select the set view and change the view that you want to select. So let's say I want to access my UV viewport. Just click on the UV viewport. Now I am in the UV viewport. So the short key for these viewports are the pad 1, 2, 3, 4 and 5. So the short key for the perspective view is the 1 key, and for the UV viewport the short key is 5. Okay, so let's change this to perspective. So let's create another geometry into our scene. Maybe let's create a sphere. Just click on the sphere and here onto the viewport, click on the sphere where you want to place the sphere. Okay, so now I have these manipulator handles to place our sphere where I want. Okay, so if you want to move your box, just come over here into the network editor. So right now you see we have these two geometries. We have the sphere and we have the box. So if you want to move the box, just click on the box and now we have the access to these manipulator. And if I click the sphere, now I have the access to the sphere manipulators. So I can select the move tool to move my sphere, or I can select the box from the network editor and move my box. You can also change this translation by click on this box geometry, and now right now we have these parameter for that box. So let's say if I want to move my box in the X unit, so just come here into the translate. So that is the X, that's Y and Z. So if I want to move my box in the 3 unit in the X, so just select the X and press 3 and enter. And now I have moved my box 3 unit in the X. So similarly, if you want to change the parameter for the sphere, just click the sphere and change the value from here. So let's placement of the X for the sphere, let's change this to 0. Now our sphere is in the center. So you can also change these parameter by, if you hover over onto the parameter that you want to change and press and hold the middle mouse button of your mouse, so this will bring up the incremental window. So right now I'm pressed and holding the middle mouse button, so I can select the increment. Let's say I want to move my sphere by the increment of 1. Just select the increment and move your mouse right and left to add or subtract the increment. And similarly, you can add lower increment, let's say 0.1 or 0.01. Okay, and let's switch the camera view tool again to navigate in the scene. Okay, so now let's see how we can edit our Houdini user interface. So if you want to hide the shelf, just click on this up arrow button to hide the shelf. You can always bring it back by pressing this down arrow button to bring up the shelf. Okay, so let's hide the shelf and let's hide the parameter window. So if we want to access these parameter, just press the P key on your keyboard. This will bring up your parameter window. I can make my parameter window bigger or smaller. Press P key on your keyboard to hide my parameters, and just let's click on this down arrow button to hide our play bar. And remember, we can bring it back by clicking this button again. Okay, so let me hide my play bar. And if you come into these borders, you can make these panes bigger or smaller. And let's say if you messed up with the Houdini user interface, so let me close my scene view, let me close my object view. So now let's say my viewport is completely messed up. So you can bring this viewport to default by where it says build. Just click on that and click on the reload button to reload your windows to the default. Okay, you can create your own desktop as well. So let me hide my shelf, we don't need that. Let me hide the parameter window. You can bring the parameter window again by pressing the P key on our keyboard to bring up our parameter. Okay, so let me hide the play bar. And now we can save this desktop by coming here onto the build. So if you press the save current desktop, this will override the build and I don't want that. So let's click on the save current desktop as. So let's name our desktop to my desk and hit save to save our desk. Okay, press OK. So now if I want this window to be the default startup, so I can come here into the edit, click on the preferences, and in the general user interface. So here it says startup. So where it says build, just click the my desk. Okay, and hit accept to save our settings. So now whenever I launch my Houdini, this will be my default Houdini settings. Okay, now let's see how we can import our geometry into Houdini. So the geometry that you maybe model in Blender or Maya and you exported out the OBJ or FBX file from other 3D program and you want to import the OBJ or FBX file format into Houdini. So let's see how we can import our OBJ or FBX file format into Houdini. So let's come over here into the network editor, press the right mouse button to bring up your node menu, or you can press the tab key on your keyboard to bring up your network menu and create a geometry node. So just type the geometry. So here we have the geometry node, select that. So here we have the empty geometry container. So double click on the geometry node to dive inside. So now you see we are in the geometry context. So you can tell that from this path. So here, as you can see, we are in the obj and in the geometry level. So you can go back onto the obj level by pressing this back button. So right now we are in the object level. Okay, you can press and hold the middle mouse button to navigate. Press and hold the right mouse button to zoom in and out in the network editor. Okay, so if you right click or press the tab key on your keyboard, so these are the nodes. So these nodes are the specific for the object level. So if you dive inside the geometry, now we are in the geometry context. And now if you right click on there or press the tab key, now we have the node menu that is a lot bigger. So these are the nodes that are relevant for this geometry context. Okay, so here onto the geometry context, hit tab key again and type the file node. So this is the node that we're looking for, file node, and press the P key on your keyboard to bring up its parameter, and where it says geometry file, let's select the geometry that you want to import. So I have stored my geometry onto the C drive, and that's the tire model. So select the tire.obj, hit accept. So now as you can see, my tire is imported. Okay, so here it is displaying me the UVs as well as the back faces. So if you don't want to see these UVs, just come over here. So these are the display options. So from the display option, just click on this checker icon to disable the UVs. Okay, and if you want to hide the wireframe, just come over here onto this box, select and choose the smooth shaded to hide our wireframe. And right here we have the tint back facing option. So if you click on that, now the back faces tinting has been off. And if you want to enable that, just click on this button again to enable the back face tinting. And similarly, you can enable the UV checker by clicking on this UV checker button to enable the UVs. Okay, so let me disable the UVs. So right now my model is big. So if I want to place my object into the center of the scene, so let's create another node for that. So press tab key in the network editor and type the match size. Select that node and connect this node to the match size and set the display flag to the match size. Okay, now we are viewing the effect of the match size node. So the match size node place our geometry into the center. So let me make my parameter window bigger. So here it says translate. So the translate is checked on. So if I disable, now the translation has been disabled. So let's check the translate. Okay, so if I want to make my tire to sit on the floor, so here is where it says justify Y. Let's change this to minimum. So now my object will sit perfectly onto the floor. And you can also make your geometry onto the unit size, which means its size will be 1 by 1. So just click onto the scale to fit. Now my tire is exactly in the size of 1 unit. Okay, so where it says target size, you can set your size. Just press and hold the middle mouse button to bring up my incremental window. So here I can adjust the size, unit size for that. Okay, so let me change this to 1. So that's how you can import your geometry. Now let's talk about grouping the geometry in Houdini. So let's create a geometry node. So this is an empty geometry container. So press enter on your keyboard to dive inside on the geometry container. And here let's create a test geometry rubber toy. And let's also create a test geometry pig head. And let's also create a test geometry squab. So we have these three test geometries. Okay, so if we set the display flag to the pig head, now we can see the pig head. And if we can set the display flag onto the squab, now we can see the squab. So if we want to see all of them, we need to merge all of these geometry. So let's create a merge node, and let's connect all of these nodes to the merge node and set the display flag to the merge node to see all of our geometries. Okay, so now the geometries are at the origin, so let's displace them. So let's create a transform node and connect the transform to the merge node. Press P to bring up the parameter of the transform node. So if we move in the X, now as you can see, all of our geometry is moving. So because the transform node thinks that after the merge, all of these geometries become a single geometry. So we need to limit the effect of the transform node to affect only one of these geometries. Okay, so we can do that by creating the groups. So let's create a group node. Let's connect that in here. So if we set the display flag to the group, so here as you can see, all of the geometry has become yellowish. So it means that these are the geometry that are in the group node. So we can name the group. So let's call this one to be rubber toy, and the group type is set to primitive. You can change this to points. Now all the points, now this is a points group. You can also change this to edges, and now this is a edge group. So we can tell that if you press and hold the middle mouse button on the node, so hover over to that node and press and hold the middle mouse button to have access to this window. So here as you can see, we have the points, 12,000 points and 12,000 primitives. And if you come down here, as you can see, we have the edge group named rubber toy. And if we change this to primitive, and now if we middle click, now you see we have the primitive group and the group name is rubber toy. Okay, so let's create another group node for the pig head. So let's create a group node, connect that and set its group name to be pig. And let's create another group node for the squab. So let's name this to squab. And now if we come onto the transform node, so here onto the group, so if you click on this down arrow button, so here as you can see we have some of these groups. So here if we middle click on the test geometry pig head, so here as you can see we already have some groups. On the primitive group we have the pig eyes, pig face and pig neck. Okay, so if we middle click on the rubber toy, so here we don't have groups. So in the squab, and we also have some groups for the squab as well. So let's delete these groups, we don't need them. So let's add a group delete, and let's connect that, and here type the star to delete all of these groups. So now if we middle click on the group delete node, so here as you can see now we don't have any groups. So let's add a group node for the pig head as well. So press and hold the Alt key on your keyboard and drag the node to duplicate the node, and let's connect that for the pig head. So now if we middle click, now you see we don't have the groups for the pig head as well, and on the rubber toy we don't have any groups. So now let's go back onto the transform node and into the group. So let's select the pig, and now if I transform here, as you can see, now only the pig has been rotated. So let's create another transform node, and onto the group. So click on this drop down arrow and choose the rubber toy, and now let's move the rubber toy, and also let's create another transform for the squab as well. So let's connect that and change this to squab, and let's move to have the effect on the squab. Okay, so now let's see different techniques for grouping the geometry. So let's create a test geometry rubber toy, set the display flag to the rubber toy, and for this example let me uncheck the add shader and click on this checker icon to hide the UV's visualization. So now on the viewport we're not visualizing the UVs. Okay, and let's add a group node and set the display flag to the group node. So here onto the group, here as you can see we can set the name for our group, and where it says base group, so here you can type the primitive number because the group type is set to primitive. You can also change this to points now. So when you type the point number, so that point will be included in the group. So for example, let me change this to primitive, and here onto the visualizer let me check the primitive numbers. So here as you can see we have all of these primitives, and these are the primitive numbers. So let's say if I want to group this 6350 primitive to the group, so let's type the primitive number here. So the primitive number is the 6350, and now as you can see only this primitive has been included in the group. Okay, so now let's add all of these rows into the group. So we can say that 63 and 6357. So press space and type 63 and 57, and now this primitive has been included in the group as well. Okay, and you can also create the groups by clicking on this arrow icon. So if you click on this arrow icon and go into the viewport, now as you can see the primitives has been highlighted, so you can manually select the primitives that you want to be included in the group. So let me select this patch and press enter, and now as you can see that our base group has been filled with all of the primitive numbers that I have selected in the viewport. Okay, so let me disable the base group. You can also group the geometry in the bounding region, so let's enable that. So here as you can see we have the bounding box at the center of our geometry, so we can change the size of our bounding box. We can move the bounding box. Okay, so now all of the primitives that are in the bounds are included in the group, and you can also change this to points. Now our group type is the point group. Now we are grouping the points. Okay, and onto the bounding type we have the bounding sphere. So now there is a sphere in the viewport, so all of these group in this spherical region will be included in the group. And you can also change this to bounding objects. So the bounding object mean you can manually create your own bounding box geometry. So let me create a test geometry pig head. So here we have the pig head. So onto the group node, here as you can see we have two inputs. So let's connect the second input to the pig head and set the display flag to the group. And here onto the group node, let's change the bounding type to bounding object. And please note that the bounding object only supports points and the vertices group only. So as you can see, we have the pig head, so where our pig head is intersecting with the geometry, so all of these are included in the groups. And the bounding object only support the points group. So if I change this to primitive, here as you can see our group sop throws an error because it can't support the primitive group onto the bounding object. So you have to be on the points group to group the geometry. Okay, so let's uncheck the keep in bounding region, and here we have the keep by normals. So let me change this to primitive. So here we have the normal direction, and here we have the spread angle. So here as you can see, the geometry has been grouped according to the normals that are facing in the z direction. So that direction, because set it to z, so we can change this to y. So let's onto the y, set this to 1 and set the z to 0. So now as you can see, so for the primitives that have the normals pointing upward are included in the groups, and we can also change this to x. So now onto the x direction, the normal spread angle, we can adjust the spread angle to include more primitives into our group. Okay, and here we have the option include by edges. So here we have the min and max edge angle, so let me change this to edges. So here you can define the min and max edge angle to be included in the groups. So and you can also group the geometry by the edge length. So minimum edge length, so let's increase the value. So for this example, let's create an A grid. Let's change the rows and column to 4 by 4, and let's select the selector tool from the tool menu, and here onto the primitive selection, let's change this to edges, and let's select these side edges, and here onto the viewport, hit tab on your keyboard to bring up the tab menu, and let's add a poly extrude node to extrude our geometry. So here let's select that. So here as you can see, now we have the different length of edges. Okay, so now let's create a group node. So let's change the group type to edges, and let me disable the base group and check the include by edges and the minimum edge length. So let's increase the minimum edge length amount. Okay, so here as you can see, all of these edges that has the edge length of 3.7 or higher are included in the groups. Okay, so if we change this to max edge length, so let's increase that. Okay, so here as you can see, so we are limiting the edge group to max of 3.6. So only the edges that have the length of 3.6 or lower are to be included in this group. So basically what it's doing, it's measuring the length of each edges, and it's comparing by this value. So if the edge length are in that criteria, so these edges will be selected and included in the group. Okay, so let's uncheck the max edge length, and here we have the unshared edges. So all of the edges that are not sharing the point, these are selected. So It is very useful option for selecting these boundary edges. Okay, and here we have the keep by random chance. So if we enable that, so here we have the percentages. So now randomly our geometry will be selected into the group. So we can change this to a primitive group. So here, as you can see, now the group SOP is randomly selecting the primitives to be included in the group. Okay, so let's create a sphere create, and set the display flag onto the sphere, and right click and home all to frame our geometry. And here let's increase the rows and columns to add more divisions into our geometry. And let's create a group SOP, and let's connect that. Set the display flag to the group, uncheck the base group, and include keep by random chance. So here we can adjust the percentages, and here we have the global seed, and let's add a poly extrude node, and let's connect that to the poly extrude node. And here onto the group, let's select our group 6, or maybe let's rename our group to be random polys. And here onto the poly extrude, let's select our random polys group and increase the distance to add an extrusion. So here, as you can see, now we are randomly extruding our geometry. So divide into where it says connected components. So let's change this to individual elements to have the extrusion onto these individual primitives. Okay, so let's increase our distance and go back onto the group. We can change the percentages, and we can also change the seed to create a different random selection. Okay, so that's how you can group geometry inside of Houdini. Now let's talk about attributes. So let's create a geometry node and dive inside, and here let's create a test geometry rubber toy. Press P to bring up the parameter, and from here let me uncheck the add shader, and let's uncheck the checker icon to hide the UV's visualizations. And let's create a color SOP to color our geometry. Press Shift Enter. So when you press Shift Enter, so the node is created and the display flag is automatically set to the newly created node. So let's try that again. So the node has been selected. So when the node is selected, hit Tab. Let's add a color attribute and press Shift Enter to create new node and set the display flag to this newly created node. Okay, so now the color SOP has been added. So let's change the color of geometry to red. So now if we middle click on the color SOP, so here as you can see we have 3-point attributes. We have the CD. So the color SOP is creating an attribute called CD, which means color diffuse, and it's a 3-float color. And also we have the N, which are storing the normals, and we have the P for the position. So we can see this attribute by going to the geometry spreadsheet. So here as you can see we have the P for the position, and here we have the point position of X of all these points, and the position of Y and Z, and here we have the CD. So here we have 3 components for CD. We have R, G and B. So for the R, the value is set to 1, and for green it's 0, and blue for 0, and we have the normals. Okay, so we can also set this our CD attribute onto the primitive level. So where it says class, let's change this to primitive. Now as you can see the CD has been gone from the point level. So we can go on to the primitive level by selecting the primitive button. So now as you can see, our attribute has been promoted to primitives. Okay, so let's take another look at the attribute. So let's create an add shop and set the display flag to the add shop, and here where it says number of points, click on the plus button to add a point. So if I click this point visualizer, so here as you can see the point has been visualized in this blue. So we can create another point, so click the plus icon to add another point, and here we have the point position. So let's displace the point position in the X. So here as you can see we have another point, so let's add another point by click the plus button, and now we have 3 points. So let's move this point further. So if we middle click on the add shop, here as you can see we have 3 points. So let's create an attribute by attribute create, connect that, and onto the attribute create we have the name of the attribute. So let's name this to my attribute. So if we go on to the geometry spreadsheet and onto the point level, here as you can see we have created the attribute name my attribute, and its value is set to 0. So we can set the value here. So here we have the value set to 0. So let's change this. So here as you can see, as I'm increasing the value, here as you can see onto the point we have the my attribute value changing as well. So here we have the size, so it is saying that how many components of this attribute will have. So we can increase this to 2. Now as you can see we have the 2 components, so we have the 0 and 1. We can also change this to 3. Now we have 3 values, so we can adjust these values from here. So that's the first value, and that's the second, and that's the third. So for easier to work with, maybe let me remove all of these points, and let's duplicate the add node. Okay, so go into the scene view, let's add a displacement, and let's duplicate again by press and hold the alt key and drag the node to duplicate the node, and let's move this further, and let's merge all of these add node by creating a merge node. And now as you can see we have 3 points. So shake this node off and connect this here. So here we have the my attribute and the size is 3. So let's decrease the size to 1. So only now this value will be considered and all of these will be discarded. So we're going to change this to 0. Doesn't matter. So if you go into the geometry spreadsheet, so here as you can see for the first point we have the my attribute and its value is 1.3. So let's duplicate this attribute create by press and hold the alt key and dragging the node, and let's connect it here. And for this let's change this to 2, and let's drag that again and connect it onto our third point, and let's change this to 3. So now if we click on the merge node to view the geometry spreadsheet for the merge node, so here as you can see now we have these 3 points and we have the my attribute set to 1.3, 2 and 3. Okay, so now let's copy our rubber toy onto these points. So we can copy this by adding a copy to point shop, and copy to point shop has 2 inputs. We have the geometry to copy, so this is the geometry that I want to copy, and the target points to copy to. So these are the points that I want my geometry to be copied. So let's select that and set the display flag to the copy to point shop. So now let me disable the point visualizer. So now as you can see we have 3 rubber toys copied to these 3 points. So maybe let's displace them. So go into the add, onto the position, let's change their positions. And for the second point position, let's displace this as well. And now, as you can see, we have these 3 rubber toys. So now let's scale these rubber toys. So copy to point sop, understand the p-scale attribute. So if the p-scale attribute exists onto these points, the copy to point sop will use the attribute to scale these geometries. So here onto the my attribute where it says, let's name this to p-scale. Okay, so now the p-scale has been set to 1.3 for the second. Let's change this to p-scale as well. And for the third one as well. Now as you can see, we have set the scale of our geometry by using the p-scale attribute. So if we select the copy to point and click on this question mark icon to bring up its help card. So if we scroll down and click on the instancing point attributes. So here as you can see, these are the attributes that copy to point sop understand. Okay, so here is the p-scale, so it means the uniform scale. Okay, so if the p-scale attribute exists onto these points, so if you middle click, you see now we have created the p-scale attribute. So the copy to point sop will use this attribute to set the scale of the geometry. So if we go into the attribute create, and we can adjust our geometry scale by increasing the p-scale value, and we can change the scale for the second point as well. Okay, and we can also set the color attribute onto these our points, and the copy to point sop will use the color attribute to set the color for our geometries as well. So let's add a color sop and connect that. So here I want my first point to be red, and let's duplicate our color sop and connect to the second point. And for the second point, let's change this to green, and let's duplicate the color sop as well and change this to light blue. So now as you can see, our copy to point sop is using the color attribute from these points and setting the color of our geometries accordingly. Okay, so now let's take a look at another example. So let's create a file node and set the display flag to the file node, and from the file select the tire model that I have provided, hit accept. So here as you can see, we have the tire. So after that, let's create a match size node, and here onto the match size, click on justify y to minimum to sit our tire onto the floor. Okay, and now let's create a rubber hair for our tires, and I want my rubber hairs to be grow onto these peaks. I don't want the hair to grow on the inside of the tire in these inside ridges. Okay, so for that, let's create an attribute. So we can say mask by ambient occlusion. So let's connect that and set the display flag to mask by ambient occlusion. So if we middle click onto the mask node, here as you can see, we are creating a point attribute named mask. Okay, so the mask attribute is set from here. So mask. So we can visualize our mask by clicking on this icon to visualize our attribute. So this is the mask. Okay, so from the calculate occlusion. Let's decrease the bias. And here on to the remap ambient occlusion mask. Let's check that. And let's scroll down. So here we have the ramp to adjust our attribute. So click on this button to maximize our ramp. And maybe let's zero out all of these values that have a lower value. Okay, so now as you can see, we are only selecting the top part of our tire. Okay, so now we are masking our geometry, and I also don't want to be here to be grown onto the side as well. So let's create a group for that. So after the mask by ambient occlusion, let's create a group node. Connect the group node and set the group type to points and check the keep in bounding region. And for the bound, let's create a tube to create and connect this to our second input and onto the group node. So bounding type, let's change this to bounding object. So here we have the tube. So let's change its orientation to z-axis, and let's move our tube up by increasing its center y, and let's increase its radius. So both of the radius. So click on the radius and let's increase that by a lower increment value, and let's change our y position as well, and let's increase our height to include onto the back side of as well, to cover our back side of our tire geometry. Okay, and now go on to the mask by ambient occlusion and go on to the top where it says group. Let's type our group name. So the group name is set to group 1. So let's type that, group 1. And now as you can see, only the points that are in the groups are being included in the ambient occlusion calculation. So if we add a exclamation mark first and now type the group name, so now it means that exclude every point that are in the group. Okay, so basically we're doing a invert operation. Okay, so all of these points that are in the groups are excluded from the ambient occlusion calculation. Okay, so here we have the mask attribute. Let's create a scatter sop and connect the scatter sop to mask by ambient occlusion node to scatter some points. So here as you can see, we have some point. So click on the point display to visualize our points. So let's uncheck the relax iteration and let's increase the point count. So now as you can see, the scatter sop is scattering the points onto all of our geometry. So go into the scatter sop and let's check the density attribute. So now the scatter sop is throwing an error because there we don't have the density attribute. So let's change this to mask because we created an attribute named mask. So now as you can see, now the scatter sop is using the mask attribute to scatter only onto the red area. So we go back onto the mask by ambient occlusion and click this button again to hide our visualization, mask attribute visualization. Okay, and now let's create a line. So here we have the line, and let's create a copy to points node. So this is the geometry that I want to copy and these are the points. set the display flag to copy to points. So the orientation is not correct. So let's go back onto the line and change the direction from Y to 0 and set the Z to 1. And let's lower our length scale. Okay, so now here, as you can see, we are copying these here. So let's merge it with our original tire geometry. So let me bring this onto the side. So here we have the original tire node. So let's merge this with these here. Okay, so let's color these rubber here to black. So let's add a color swap, and here let's change this to with gray, and we can also change the length. And go into the scatter sub. Let's decrease the number of hairs to a lower value. Okay, we will take a look at these attributes more detail as we progress through the course. Okay, so maybe let's calculate the ambient occlusion for all of our geometry. So for that, so here as you can see, we have these lines. So let's add a thickness to these lines by adding a sweep swap. So let's connect that, set the display flag to sweep, and now the sweep is throwing an error because it needs a shape node for the sweep. So let's go into the surface shape, which says that second input cross section. Let's change this to round tube to create a round tubes, and let's lower these radius to a lower value. Okay, and let's disconnect this wire. So if you press and hold the Y key on your keyboard, now as you can see the cursor has been changed. So if you drag, you can cut the wire. Okay, so and let's connect the sweep onto the merge node. So here as you can see, we have the tubes geometry for our hair, and let's add a mask by ambient occlusion to calculate the occlusion. Set the display flag to the occlusion node, and after that let's create a color swap. Connect that, and here onto the color, and the color type is set to constant. So let's change this to ramp from attribute, so we can use the mask attribute. So this attribute that the mask by feature has been created, so we can use this to color our geometry. So where it says attributes, click on the drop down menu and choose the mask to use our ambient occlusion as a color. So now as you can see, we are calculating the ambient occlusion and use the mask attribute onto the color sub to visualize our ambient occlusion. So let's change this to smooth shaded and go into the mask by ambient occlusion. We can change the bias to create a more intense ambient occlusion. Okay, so we will take a look at these attributes more detail and in depth as we progress through this course. Okay, now let's take a look at transferring the attribute from one geometry to another. So let's create a geometry node and dive inside, and here let's create a grid. So here as you can see, we have the grid, and let's also create a sphere. So here we have the sphere, and for the sphere let's set a color attribute by adding a color swap. Connect that, and let's change its color to red, and let's duplicate the color node and set its color to black. And now I want the sphere red color to be transferred onto the grid. So we can do that by adding an attribute transfer node. So attribute transfer has two inputs. So the geometry to transfer attributes to and the geometry to transfer attributes from. So set the display flag to the attribute transfer, and here you can define these attributes that you want to transfer. So if no attribute is selected, which means every attribute will be transferred. So let's uncheck the primitive, so because we don't have primitive attributes, and let's specify the attributes that we want to transfer. So click on the drop down menu and change this to color. So now if you go on to the condition, so here as you can see we have transferred the red color from the sphere onto the grid. So before we have the grid colored black, and after the transferring you see red color has been transferred. And we can narrow the area so where we want to be attribute to be transferred. So if you go on to the attribute transfer into the condition, let's decrease the distance threshold to lower value. So here as you can see, so let's go on to the grid and let's increase its rows and column to add more geometry. So if we change this to smooth wire shaded, as you can see we are adding more geometry. So let's change this rows and column to 100 by 100. Now if we set the display flag, now as you can see we are transferring the attributes where our sphere is located in 3D space. So if we template our sphere, so if you hover over to that node and click on this template icon to template our sphere, so here as you can see our sphere has been templated. So let's go on to the attribute transfer and let's lower the distance threshold until it matches with our sphere, or maybe let's zero out the distance threshold and let's increase the blend width to create a more smoother fall off. Okay, so now if we move our sphere, as you can see our color is moved as well, because we are transferring the attribute based on where the geometry is located relative to the grid in 3D space. Okay, so that's how you can transfer attribute from one geometry to another. So let's take a look at another example. So let's create a sphere. So let me untemplate the color node. So this is the sphere, and let's duplicate the sphere node one more time to create another sphere. So here on the primitive type, let's change this to polygon, and let's increase the frequency to add more divisions. And here let's create a attribute noise sub to create a noise attribute. So here as you can see the attribute noise is noising up the CD attribute, and it is a vector. So let's change this to float, which means one value. So now as you can see our noise has been visualized in black and white. So let's change this to smooth shaded again, and let's lower the element size. And now let's transfer this noise attribute to our original sphere. So go on to the sphere and let's initialize our first attribute, or maybe let's change the attribute from CD to extrude, because we are gonna use this attribute to drive our poly extrude node. So let's name this attribute to extrude, You can also use the CD attribute as well. So I'm using the extrude attribute. So let's here create an attribute create sub, and let's name this to extrusion or extrude. Okay, so now the extrude attribute has been created. If we go into the geometry spreadsheet, you see we have the extrude and the value is set to 0. And now let's transfer our noised extrude value onto our original sphere. So let's create an attribute transfer node. Connect this to first input, and this will go into the second input. Set the display flag onto the attribute transfer. And so because we are going to use the poly extrude node, so this node, so because the poly extrude will extrude our primitives, so these primitive, so the attribute must be exist onto the primitive level. So if we middle click, now you see we have the extrude onto the point level. So let's change that. So select the attribute create and the class set to point. Let's change this to primitive, and here onto the attribute noise, the attribute class is point. Let's change this to primitive. And now if you middle click, now you see we have the primitive attribute extrude. So go into the attribute transfer, uncheck the point, and onto the primitive, let's select the extrude attribute. So we are transferring the extrude attribute. So we can visualize our extrude attribute by adding a color sub and connect that. And here the color type is set to constant. Let's change this to ramp from attribute, and our attribute exists on the primitive level. So here onto the class, let's change this from point to primitive, and from the drop down menu let's select the extrude. So here as you can see we have the extrude value visualized. So now let's connect the poly extrude node, and onto the poly extrude node go into the local control and turn on the local attribute distance scale, and our scale attribute name is, we set it to extrude. So let's change that extrude, and now this distance scale will act as a multiplier, so which means we need to increase it to have an extrusion and divide into where it's a connected component. Let's change this to individual elements to be extrusion happen to the individual primitives. Okay, so let's go back onto the sphere and maybe let's increase its rows and columns to create a more detailed geometry. And here onto the attribute transfer, go into the condition, and let's lower the distance threshold to 0, and let's increase the blend width. Okay, so now if we transform, let's add a transform node. So this is our noised attribute that we have created. So let's add a transform. Okay, so let's set the display flag to poly extrude, and if we move our sphere location, now as you can see we are adding an extrusion based on the location of our sphere. So maybe let's increase its scale a bit higher. Okay, and select the transform node and press enter to have access to its manipulator. So select the Y handle to move our sphere up and down. Okay, so now as you can see we are extruding our geometry. So the extrusion is only happening where our attributes have a higher value. Okay, so we can go onto the attribute noise, and let's uncheck the output raw value to create a more extreme extrusion. And you can also play around with the noise element size, and you can also animate the noise. So if I bring up my play bar and hit play, now as you can see we are also animating our extrusion. So that's how you can transfer attribute. Now let's take a look at copying the multiple geometries onto our points. So let's create a geometry node, dive inside, and let's create a test geometry rubber toy and a test geometry squab and a test geometry pig. So let's merge all of these three geometries by creating a merge node. Select all three, and let's set the display flag to merge. Now as you can see we have merged all of our three geometries. And for copying, let's create a add node to add a point. So P to bring up its parameter, number of points, click on the plus button to add a point at the origin. Let's duplicate that node again, and here let's add a offset. Let's duplicate it again, and let's add further offset, and let's merge all of these 3 points. So if we middle click, here is, as you can see, we have 3 points. So now let's create a copy to point sub, and these are our geometry and these are our points, and let's set the display flag to the copy to points. And now as you can see all of our geometries have been copied onto these 3 points. So when we merge these 3 geometries, the copy to point sub thinks that all of these 3 geometries are in fact a one piece of geometry. So the copy to point sub has no way of knowing on which geometry to copy onto the which points. So for that let's create an attribute. So let's add an attribute create, and let's create a name attribute for our geometries. So let's connect that. So here onto the attribute name, let's name this to be a name attribute. So the name is a string, so here onto the type where it says float, let's change this to string, and let's name our rubber toy to be rubber toy, and let's duplicate this node again, connect it here, and let's name this squab, and duplicate it again, and let's name this to be pig. So now we have created the unique name attribute for our geometries. So we need these name attribute onto these points as well, so that copy to point sub knows which geometry to copy to which point. Okay, so let's connect first one to the first point, second one to the second point, and third one to the third. Okay, so now if we middle click, you see we have the name attribute. We can go into the geometry spreadsheet and click on the merge node to view its geometry attributes. So here as you can see we have created a name attribute, and for the point 1 we have the rubber toy, and point 2 we have the squab, and third point we have the pig. So if we set the display flag to the copy to point sub, so it's still not working. So we need to go into the copy to point sub, and let's check the piece attribute, and the piece attribute is already set to name. So now it is using the name attribute, and it is looking for the name attribute on both sides of the stream. So now the copy to point sub knows which geometry to copy onto which points. Okay, So you can manually select these name attributes from both sides, but we can also automate this. So for that, we're gonna use the connectivity sub. So what the connectivity sub will do, it will look for the connectivity of these points. So if this is an A1 connected piece of geometry, so it will name this geometry to an A1 piece. So here the attribute is set to class, so let's name this to name. So now if we middle click, you see we have created an a name attribute, so it is an a integer. So you can set this to string. So now if you middle click, you see now we have the name string and we have the 12 unique attributes. And here we don't need the name attribute. So here we have the 12 unique, and that is because the test geometry rubber toy has multiple connected geometries. So if I select my selector tool and here onto the select, let's check the 3D connected geometry. So here as you can see, this is a one single connected piece, and this is another, this is another. Okay, so to fix that, let's add a pack sub to pack our rubber toy geometry. So if I middle click, you see I have a 12,000 points. So when I connect the pack sub, and now if I middle click, now you see I have 1 point. So basically we are packing our geometry. We will talk more about pack primitives more detail later in the course. For now, let's add a pack, and now you see we have an A1 pack geometry. So now if we set the display flag onto the connectivity sub and middle click, now you see we have the name and we have 3 unique name attribute. Okay, so let's delete the name attribute from here as well, and let's see how we can transfer this name attribute onto these points as well. So because we need the name attribute onto the points so that the copy to point sub knows which geometry to copy onto which point. So for that, let's create an attribute from pieces sub. So the attribute from pieces sub has 2 inputs. One is the point cloud, so that is our point cloud, and the second, the geometry library. So this is our geometry library. So now the attribute from pieces sub is copying the name attribute from this stream to these points. So let's connect that, and now if we set the display flag onto the copy to points, now as you can see we are copying multiple geometries onto these points. So which means I can create more points. So let's add a grid. So let's delete that, we don't need these. So here we have the grids. Let's connect the grid into the attribute from pieces, and now let's set the display flag on copy to points, and now as you can see we are copying multiple geometries. So let me make the grid scale up bigger. Maybe let's lower the rows and columns. Okay, so whenever you connect another geometry, let's say create a platonic solid, and if I connect this into the merge, now as you can see the platonic will add it automatically. Okay, so here onto the attribute from pieces sub we have the name attribute distribution. So the mode is set to cycle, so which means that it is cycling. So for the first point, so if I set the display flag onto the grid and enable my point number, so here we have the point 0, 1, 2, 3 and 4. So the attribute from pieces sub is cycling these geometries. So we have the 4 geometries, so it will assign the first geometry onto the first point and to the second and third and etc. So if we set the display flag and let me hide the point number, so now we have the rubber toy, squab, pig and the platonic. We can change the distribution from the attribute from pieces, so where it's a mode cycle, let's change this to patches, and now we are distributing these objects using these noise patches. So here we have the scale of the individual patches. You can also use the noise. So now we are using the noise to set the name attribute. You can also change this to random. Now the object will be copied randomly onto these points. I can offset it, and here is the random seed. Okay, so that's basically how you can copy multiple geometries. Now let's take a look at scatter and align sub. So let's create a geometry node and dive inside, and for this example I'm going to create a grass blade. So for that, let's create a line sub and bring up its parameter, and let's set its length to 2 units. Okay, and let's add a sweep sub, and here onto the surface shape let's change this to ribbon. So here we have the ribbon. So let's check apply scale along curve, and let's scale the upper side to be lower value to create a more pointier grass blade, and let's change the interpolation to B-spline to have a smoother interpolation, and for the first point let's change this to B-spline as well, and in the middle let's add another point. Let's bring this point down and the first point down as well, and as you can see at the middle the scale is not working, and that is because if I enable the smooth wire shaded, as you can see we don't have the height segments. So for that let's go into the line. So here as you can see on the line we only have 2 points, so the sweep sub use these points to add a height segments. So here onto the line let's increase the number of points. Okay, so now as you can see by increasing the line number of points I'm adding the height segments. Okay, so let's go back and let me hide the point display, and let's create a very basic grass blade. Let's lower the base scale down, and let's lower the tip scale, something like that. Maybe let's remove this point. Okay, so let's add a bend deform to bend our grass blade. So press enter on the bend node to enable its manipulator. So the capture axis is not correct, so here onto the capture direction let's add the y-axis 1 and 0 out the z-axis, and now we have the correct direction to bend our grass. Let's move the bend deformer up by changing the capture origin. Let's move it up, maybe there. Okay, and now let's create a circle, and let's change this to ZX to sit on the floor, and let's use the scatter and align sub. So the scatter and align sub is the modified version of the scatter sub, this one. So the scatter and align sub has some features. So when scatter and align sub scatter the points onto the geometry. So let me change the point count method is set to by size. Let's change this to by density. Let's increase the density. So here, as you can see, we have some points, and let's increase the coverage area to 1 to fully cover our circle. So the scatter and align sub, when it scatter the points onto the geometry, it is creating some attributes. So if we middle click, you see we have the N, so it is creating the normal, and the orient, so orient is an A4 float, which means it's an quaternion, and it's adding an AP scale and an A tag. So let's add an A copy to point. So these are grass blade and these are our points. Set the display flag to copy to points. So here, as you can see, the scale is not correct, so go into the scatter and align onto the attribute. Let's uncheck the radius attribute, P scale attribute, we don't need that. Okay, so the grass blades are pointing on the wrong direction, and that is because if we set the display flag onto the circle, as you can see, the circle is facing on the downward. So let's add a reverse node to reverse the facing direction of the circle. Okay, and now let's hit the display flag onto the copied points. Now, as you can see, our grass blades are pointing correctly. So let's go into the scatter and align. So here we have the rotation around normal. So let's change the max angle to 360, so which means they are allowed to rotate randomly from 0 to 360 degrees. And let's enable the max cone angle to add a spreading effect. Okay, and let's increase the density to a higher value, and let's uncheck the back face tinting. So by clicking on this button, tint back facing polygons. Okay, and now let's randomize the scale of these grass. So let's create an attribute randomize, and let's connect that. And the attribute randomize is randomizing the CD, which means the color attribute. So let's change this to P scale, and the P scale only has one value, so let's change the dimension to 1 and the distribution method to exponential. Okay, so now the scale is huge, so let's lower the global scale down. Okay, or maybe let's decrease it even further and go into the scatter and align, and let's increase our density. Okay, something like that. Okay, let's create a grid. Set the display flag to the grid and press enter to access its manipulator, and let's scale the grid down onto the y-axis. Okay, and now let's connect our grid into the scatter and align. So let's remove the circle, we don't need that. So here we have the grid, and now if we set the display flag onto the copied points, now as you can see we are making the grass onto the grid. Okay, so here onto the scatter and align, let's go on to the point generation, and let's decrease the relax iteration to 0. And now if we set the display flag, So if we had enabled the relax iteration, here as you can see the grass is spreading evenly across the grid, and I don't want that, so let's make the relax iteration to 0. And here onto the scatter and align, let's check the density attribute, and let's click on this brush icon to create a density attribute. So now we are on the attribute paint tool. So let's increase the brush size. For increasing the brush size, the shortcut is the Control Shift and press and hold the left mouse button and drag. So Control Shift and press and hold the left mouse button to drag to increase the brush radius, like so. And let's paint it across in this direction and also on this direction as well. Let's add another stroke to create a more dense space. Okay, now let's go back to our camera view tool. So here we have created a path. Okay, so let me organize the node. So when we click this icon, it will created a attribute paint shop, and after that it created a density attribute and initializes it to 0, and then we are painting, we're using the attribute paint shop to paint our density attribute. Okay, now let's add rocks into this path. So here onto the grid, let's create a scatter and align shop, and here let's change the point method to density, and let's increase the coverage area, and let's increase the density scale, and go into the point generation. Let's lower the relax iteration to 0, and let's create a basic rock model. So let's create a sphere and change the primitive type to polygons, and let's increase the frequency to add more divisions, and let's add a mountain shop, and let's change the noise type from simplex to Whirly Cellular F1. Okay, so now it's starting to more look like a rock. Let me change this to smooth shaded, and let's add another mountain to add another noise on top of that. So the method is set to add, which is correct, and let's lower the amplitude down to maybe 0.1 so that we have a little bit of bumps. Okay, so now let's organize these nodes, and let's add a copy to point sub to copy our rocks onto these points. So set the display flag onto the copy to points. So here onto the scatter and align, go into the attribute, and let's uncheck the p-scale attribute. We don't need that. So let's create a attribute randomize, and let's connect that, and here let's randomize our p-scale, and the dimension is 1. And here onto the scatter and align, let's go into the orientation, and let's change the max angle to 360 degrees, or maybe let's lower the density count by decreasing the density value. And let's add a spread by changing the max random cone angle. So let's increase that. Okay, something like that. Now let's merge our rocks with the grass. So let's create a merge node. Let's connect these grass with these rocks. Set the display flag onto the merge. And now as you can see, we are scattering the rocks and the grass as well. Or maybe let's go back onto the line and let's decrease its length to 1.5. And let's go into the sweep shop and let's adjust the RAM parameters to create a more thinner grass. So that's basically the scatter and align shop. So here we have the round to multiple of, so which means we are constraining the angles in by this value. So to explain this option, let me create another grid and set the display flag onto the grid, and let's use the scatter and align shop. Connect that, and here let's change the coverage to 1, change this to by density, let's increase the density, and let's create a line shop, and let's create a copy to points. Now let's change this direction Z to 1 and Y to 0. Okay, and here onto the scatter and align, let's uncheck the P scale attribute, we don't need that. And here onto the orientation, here we have the min and max angle, so let's increase it to 360 degrees, and let's check the round multiple. So we can say whenever we are rotating over these points, they are allowed to take 90 degrees turn. Okay, so here as you can see, now our lines are rotated and they are exactly taking the 90 degree turns. So let's create a polywire after the copy to point shop, and let's uncheck the UV visualization, and let's increase the wire radius and also the divisions to create a more smoother tube shape. Okay, so here as you can see, we are creating some sort of piping network. Let's decrease the density and let's increase the length. Okay, so that's the scatter and align shop. Okay, now let's talk about copying the geometry onto curves. So let's create a geometry node and dive inside, and to draw a curve, so add a curve Bezier node, and when the node is selected, press enter to access its manipulator and start drawing curve. So you can press and hold the left mouse button to add a Bezier handles, and all of the tools shortcut are listed here at the HUD. Okay, and press enter to complete your curve. And for this example, I'm not using my own drawn curve, so I'm gonna be using the helix shop instead. Okay, so let's add a helix shop. So the helix shop will generate a helix shape. So here we have the height, and here we have the turns. So let's increase its height, and now let's create a test geometry rubber toy, and let's add a copy to point shop. So let's connect our geometry into the geometry slot, and let's connect our curve into the target points. Okay, set the display flag onto the copy to points. So here we are copying the geometry onto the curve. So let's increase the helix scale. So let's go into the transform, and let's increase its uniform scale. Zoom out a bit. Okay, so here, as you can see, we are copying our geometry onto the curve, but the orientation is not correct. So for correcting the orientation, we need the orientation information onto the curve. So if we middle click, you see we only have the point position information. So if I enable my point display, so here as you can see we have the points. So these are the points in 3D space. So we only have the point position information, but we don't have the orientation information. To add the orientation, we can use the node called orientation along curve, this node. So let's connect that. So let's set the display flag onto the orientation along curve. So now if I middle click, now you see we have some attribute. We have the attribute name n, which means normal, and we have an a up vector. So we can visualize our normal by clicking on this display normal button. So here as you can see we have these normals, and we also have an a up vector to visualize our up vector. So hover over to that node and click on this I button to bring up our inspection window, and click on the up attribute to add an a visualizer. So here as you can see we have the up vector in yellow. Okay, so let me hide my point display and the point normal display, and let's click on this I button again and click on this up attribute again to hide the visualizer. And now if I set my display flag onto the copy to point, now you see we have the orientation. So now the orientation is not correct. So we can go on to the orientation along curve, and where it says target up vector to curve normal, so let's change this to y-axis. So which means we are using the y-axis as an a up vector. And now here as you can see we have a very smooth transition of our geometry. So here onto the orientation along curve we have some additional control, so we can add a rotation. So go into the additional rotations. We can enable apply roll or twist. So let's add a roll to rotate. We can add a full twist, or we can add a partial twist. We can also add a yaw. So that's the rotation in a single axis. So let's enable the apply pitch to rotate our geometry in other axis. Okay, so we can add a resample node. So let's connect that. So we can use the resample node to control our number of points. So we can use the length here. So we can increase the number of points by using the edge length, or we can use the maximum segments. So here now we are telling exactly how many points we want on to our curves. Set the display flag on copy to points, and let me disable my point display. And here, as you can see, we are copying more or less geometry onto the curve. So right now the copying is very slow, because if I middle click here, you see we have lots of points. So what we can do is on to the copy to point, let's check pack and instance. So what it will do, it will pack our geometry into single points and then copy onto the curve. So now if I middle click here, as you can see, we have 51 packed geometries, and we are only using the almost 2 MB of RAM. So before that, if I middle click here, as you can see, we are using the 92 MB. So the packed geometry is very memory efficient. So we can also unpack our geometry. So if you do need access to all of the geometry points, so after unpacking, now we have our original geometry back, or onto the copy to point, uncheck pack and instance to have the same effect. So let's enable that. And now if I change my number of points, now my copy to point sub is working very smoothly. And we can also use this technique to animate our geometry along the curve. So we can add a curve sub. So if I set my display flag onto the curve, so we can change the first U to cut our geometry, or if you want to start on the other way, let's disable the first U and choose the second U. Now you can cut your curve on the other direction. So let's enable the first U. So now here, as you can see, I'm carving up my curve, and here onto the curve we have the option to extract the point. So now we are extracting only one point from our curve, and we can use the first U to change our cutting position. Okay, so basically now we have an A1 point. So if I set the display flag on copy to point and I use my first U, now as you can see, we are basically animating our geometry onto the curve. So now let's disable our curve node by hover over to that node and click on this bypass button to bypass the node. Okay, so let's go back onto the helix and maybe add a height ramp. So here let's add a point, and let's bring that position up a bit to create a steeper line in between. And now let's enable our curve node again. So we can animate this. So if you want to add a keyframe, press and hold the Alt key on your keyboard and press the left mouse button to add a keyframe at the current frame. So now the parameter has been green, so which means we have set it a keyframe. So let's go on to the frame 90 and let's change this all the way to 1 and press and hold the Alt key on your keyboard and left mouse button to add another keyframe. So now if I play, so now as you can see we are animated our geometry onto the curve. So let's enable the real-time playback by clicking the clock button. So let's hit play. And if you want to set the interpolation of your keyframe, hover over to that parameter and press and hold the shift key on your keyboard and middle mouse button press to open up the graph window. And here we have the first keyframe and here we have the second keyframe. So let's select both of these keyframes. Let's change the interpolation to linear. From here, change this to linear. So now we have the linear interpolation. So now let's hit play. Okay, and there is also a node for copying your geometry onto the curve. So it is called copy to curves, this node. So this node requires the geometry. So here we have the geometry and here we have the curve. So here as you can see we have the curve, and if I middle click here, as you can see I don't have any orientation attribute. So if I select this curve and put it into the second slot of the copy to curve and set the display flag, and let me disable my point display. So press P to bring up its parameter. So here as you can see we have the option to set the orientation. So where it says target up vectors, let's change this to y-axis. So basically the copy to curves node is a digital asset, so which means you can drive inside. So if I select the node and press enter, so now we are inside that node. So inside that node, here as you can see we have the basic copy to point sub and we have the orientation along curve node. Okay, so let me delete that. And by the way, if you are using the helix sop, or the sop is called the spiral and the helix is its preset, so the spiral sop does have some attribute. So for example, we can change the number of point. So if I enable the number of point, so here we can set the number of point, so which means we don't need the resample sop. And also it has the option to output the orientation, so where it says output attributes, so here we have the option to enable the up vector as well as the n for normal, or we can enable the orient attribute to orient our geometry. So which means we don't need the orient along curve node if we are working with the spiral sop. Okay, so now here as you can see we have the orientation. Now let's see how we can use the chain sop to copy the geometry onto the curves. So the chain sop is much more robust way of copying the geometry onto the curves. So let's see how we can set it up. So let's create a geometry node and dive inside. Let's create a line and let's increase the line length to 5, and let's create a box. So here we have a box, and let's add a chain sop. So the chain sop has two inputs, geometry to repeat and the required curves. So let's connect the line to the curves, set the display flag to the chain. So here as you can see we are copying the box onto the line, and here as you can see if I set the display flag onto the line and enable the point display, here as you can see we only have 2 points. So unlike the copy to points or curve sop, it's not using the points to copy the geometry onto the curves. Instead, it's using the curve length as well as the size of the geometry to calculate the number of pieces to fit onto the curve evenly. So if I go into the chain sop, so here as you can see the number of pieces is set to the fit pieces along curve, so which means it's using the curve length and the size of the geometry to fit as many pieces as it need to fit the curve. We can change this to explicit number. So let's say if I want to copy 6 pieces, I can set it here. So now here as you can see we have 6 boxes, and we can adjust the spacing of these boxes by going to the alignment. So here we have the piece spacing, so let's increase that. So here as you can see we have the spacing, and the chain sop also recognizes multiple geometries input as well. So let's say if I connect a sphere, and let's merge these two objects. So here as you can see the sphere has been included automatically, so I can keep adding more geometries. Let's add a platonic. Let's merge it into the stream. So here as you can see the platonic has also been added. Okay, so let's go into the chain sop and let's decrease its spacing and go into the chain pattern, and let's change the number of pieces to fit pieces along curve, and let's add a transform node to scale our geometry down. So here as you can see, as I'm scaling my geometry down, so more of the pieces are required to fit onto the line. Okay, so let's add a truss geometry rubber toy into our geometry library. So now here as you can see, because our rubber toy has multiple connected geometries and it is using the connectivity sop to determine how many geometry pieces has been connected in its input stream. Okay, so we can use the pack node to pack our rubber toy onto single point. So now here as you can see we have one packed geometry. So if I set the display flag onto the chain sop, now the chain sop is working correctly, and here onto the pattern we can cycle between our geometries. So now we are cycling by 3, which means now that the last piece has become the first piece. We can also change this to random, and we can change the random seed to randomly copy the geometry onto the curve. Let's change it back to cycle, and here we have the start and the end pieces. So which means we can define at the start of the curve which geometry we want at the start and which geometry we want at the end. So we can select that. So right here as you can see it's showing me the numbers, so we can change this to name by creating a name attribute. So let's go back into the merge, and here let's set up our name attribute. So let's create an attribute create node, and let's connect that, and let's set the name to name, and it should be a primitive, and the type set to string. Let's name our box to box. Let's duplicate this node, connect it to the sphere, and let's change this to sphere. Duplicate again, and here let's name this to platonic, and here let's set this rubber toy, and here onto the chain sop. So where it says find pieces by connectivity, let's change this to by piece attribute, and it is looking for a class attribute, but we have set an attribute name. So let's change this to name. So now it is recognizing our name attribute, and now here onto the start cap piece we have all our names. So at the start I want it to be box, and at the end I can use the platonic. So now here, as you can see, at the start I have box, and at the end we have the platonic. And here we have the checkbox to exclude end pieces from pattern, so which means that the pieces that we have defined in these slots will not be included in the geometry repetition. So we can uncheck that if we do want these pieces, and let's increase the line length. So here, as you can see, now we do have those pieces, but at the start we will have box, and at the end we will have platonic. So now let's create a chain using the chain sop. So first let's create a chain link. So let's create a grid, set the display flag to the grid, and let's set the rows and columns to 2 by 2. Let's change the size X to 1.4, 2.9, and let's add a poly bevel, and I want to bevel my points, so let's change this to points, and let's increase its distance and add some division for more smoother corners. And now let's add a polywire. Let's add some division for more smoother look, and let's uncheck our UV visualization. And let's increase the wire radius, and let's add a helix to create our curve. So let's set the display flag to the helix. Let me increase its height and decrease the turn, and let's add a height ramp. Okay, let's add a chain sop. So these are our geometry, these are our curves. Set the display flag to the chain sop. So here, as you can see, the chain sop is not working correctly, so let's change some settings. So to avoid the pieces deformation, let's go into the rigidity and let's enable the rigidity. So now here, as you can see, we are not deforming our geometry, so the geometry size is big. Let's add a transform node. Let's scale it down by changing the uniform scale to a lower value, something like that. And let's go into the chain sop and onto the alignment. Let's add a piece rotation. Let's add a rotation of 90 degree, and let's adjust our piece spacing in the negative direction. Okay, so here we have the very basic chain. Okay, and we can also use the chain sop to animate our geometry onto the curve. So if I go back onto the chain sop, so here where it says number of pieces, Let's change this to explicit number, and let's add only one geometry onto our curve, and here onto the offset position, let's increase that. So here, as you can see, by adding the offset position, so let me template my helix. So if I enable, now if I add offset, here as you can see, we are animating our geometry along a curve. Okay, so let's create another example. So let's create a box, set the display flag to the box, and let me decrease its X size, and let's add a poly bevel, and let's add some divisions for more smoother bevel. And now let's add some holes into our geometry. So let's create a grid. So here we have the grid. Let's change the orientation to YZ plane, and let's add a match size node. So this is the geometry, and let's use this box as a reference geometry, and let's enable scale to fit. So now our grid has exactly the same size as our box. Okay, now let's create a tube. Let's change its orientation to X, and let's decrease our radius down, and also add the end caps. Also increase the columns for more smoother, slender. And let's copy our tube onto the grid. So let's add a copy to points sub. So this is my geometry, and I want to use my grid points. So here we are creating lots of copies we don't need. So let's go into the grid. Let's change the rows and column to 2 by 2. So let's go back onto the tube, and let's change the orientation to Z-axis. So now they are oriented in the correct direction. So if I template my box, here as you can see, we have these cylinder in the correct orientation. Let's also decrease the radius even more. Let's add a transform node after the match size. So we are basically, let me untemplate my box. So here we have the grid. So let's decrease the grid size a little, and if I template my box again, so let's decrease the scale even more, something like that. And now let's use these cylinder to boolean out from our box to create holes. So let's add a boolean node. So this is the geometry A, and this is the geometry B, and here we have these holes. Let's duplicate our setup. So these are our tube, and this is the copy to point sub. So let's duplicate it here, and let's merge it. So here onto this tube, let's decrease its height, and let's also decrease the radius just a tiny bit, so that we can see a little bit of hole. And let's go back onto the tube. Let's replace it onto the Z direction. Something like that. So this is my piece that I want to repeat. So let's copy this setup. So where we have created the helix and the chain saw. So let's duplicate this whole setup. And let's use this as our geometry. And let's set the display flag onto the chain saw. So onto the chain saw, we have set the number of pieces to 1. Let's change this to fit pieces along curve. So the scale is not correct. So let's add a transform node to scale our whole geometry down by changing the uniform scale. And because our model is made out of different connected pieces, so that is why the chain saw is copying each pieces individually. So let's go back onto the chain saw, and where it says find pieces by connectivity, let's change this to by piece attribute. And let's go into the alignment and let's zero out our piece rotation. We don't need that. And let's change our forward direction from Z to X. So now it is using the correct direction to copy our geometry onto the curve. Okay. So let's go back onto the chain saw. Here we can adjust the piece spacing to create more or less geometry. And here onto the helix, we can adjust the height and also the number of turns. And onto the chain saw, under the chain pattern, let's go into the transformation and let's enable the scale, so we can scale our geometry along a curve. So we can enable the scale ramp. So here we have the ramp to adjust the scale, and let's enable the rotation, and let's enable the rotation scale ramp. Here we have the base rotation. Let's add some rotation. So here we can adjust the ramp to where we want the rotation to happen. Okay. So here, as you can see, our first piece is not correct. So what we can do, we can add a reverse node to reverse the direction of our helix. So here we are starting correctly, and at the end we have the ending geometry correctly. We can create another box and use this box as an end piece to add an end cap. Okay, so that's the chain saw. Now let's take a look at procedural geometry creation. So for this example, let's create a simple procedural staircase. So let's create a geometry node and dive inside, and here let's add a helix. Let's bring up its parameter. So here we have a helix. Let's adjust its height and let's make its radius to a lower value, and let's add a sweep saw. And now the sweep saw is throwing an error, so because we don't have the second input cross section, so let's change this from surface shape second input to ribbon. So here, as you can see, the orientation is not correct, So let's go back onto the helix and onto the output attribute, and let's turn on the orient attribute. So now the orientation is correct. So let's go back onto the sweep sub and let's adjust its column to 1. And for creating these step, let's add a group node, group by range. Connect that, and here onto the group range we can set the different range for the geometry selection. So let's change the parameter here onto the range filter. Let's select every one of 2. So now we are basically skipping every face, and let's name our group to steps. Let's add a poly extrude node, and for the first let's add a thickness by increasing the distance. And as you can see, we don't have the bottom piece, so let's add output back to create a more filled geometry. And now let's add poly extrude again, and here onto the group let's set our step group that we have created, and let's add its distance. So here as you can see, we are creating the steps, but when we created the thickness here onto the poly extrude node, we have the group selection on both sides. So let's remove the bottom part from it. So for that let's create another group node and connect that, and here let's uncheck the base group and go into the keep by normal, and onto the normal direction let's compare this by y-axis and zero out the z, and let's decrease the spread angle just until we can select the top side of our staircase. Okay, so let's name this group to top. So here onto the where we have created the step group, so let's disconnect it from here and connect it here instead. And here onto the group range let's select our base group to be top. So now we are only working on the top side of our geometry, and we are selecting every other polygon face. So now let's create a poly extrude. So now we have the extrusion applied correctly. Okay, so here I can go back onto the helix and I can adjust the radius, I can adjust the height as well as the number of turns. And now let's add the railing onto our staircase. So after the poly extrude let's add a blast node to isolate these faces of our steps. So let's add a blast node, and here onto the group let's select the group steps and choose the delete non-selected to create an inverted operation. Okay, so here we have these top faces of the staircase. So let me bring it here onto the side, and for creating the railing let's use the loops to loop at every steps one at a time. So we can loop at every piece by using the for each. So if you type the for, here we have the loops, so we can loop for each number, each point, each primitive, or we can use the for each connected pieces. So let's add that. So what it will do, it will add a connectivity sub to assign an attribute to all of these connected pieces and run onto each of the connected pieces separately. So if we set the display flag onto the for each end, and let's bring up its parameter of the for each end, and let's check the single pass. So here, as you can see, now we are working only on one of our step. We can change the single pass step here. Okay, and if we uncheck, now the loop is going through every single of these pieces and merging the result back. So let's check the single pass and use our first piece, and here let's add a subdivide to add more division onto our step, and let's select our center edge. So let's go into the selection tool and change the mode from primitive to edges. Let's select these center edges and type bevel. So let's increase the distance. So we can always come back and adjust its distance, okay, by using this parameter. And now let's isolate these points for placing the staircase railing rods. So if I enable my point display, so we are interested in the point 8 and the point 11. So let's add a blast node and change the group type to points, and let's select the 8 space 11 and click on delete non-selected to isolate these 2 points. Okay, so here we have these 2 points, and if we uncheck the single pass, so here as you can see we have created this operation onto each of our pieces. Okay, and let's now add a line, and let's disable the point display. Let's add a line and use the copy to point sub to copy the lines onto these points. Okay, so here we have these railing rods. Let's adjust the length to a lower value, and let's add a sweep and change this to round tube, and let's lower the scale. And let's also add these end caps by going to the end caps, change this to single polygon. So now we are adding the end caps. So let's merge this with our staircase steps. So let's add a merge node. So these are the railing rods. Let's set the display flag. So now we are creating the railing rods. So now let's connect these rods. Okay, so for that let's group our very top point. So the point number is 1. So let's add a group node and change the group type to points, and let's name this top, and we want to group our point number 1. Okay, so when we copy, all of our group will be copied as well. So let's add a blast node to isolate our top group. So here onto the blast, let's choose our top group. So here we have the top groups points. So now let's connect these points to create one single spiral curve. So let's add an add sub, connect that, and let's go into the polygon and let's change this to by group, and we are now connecting the all points. So now the connection is not correct, so they are connecting in a zigzag style, so we don't want that. So for that we can use the attribute, so we can connect these points by using the attribute. So let's select that. So here we can define the attribute, so let's create an attribute for that. So we can create an attribute at this stage where we have isolated these two groups. So if we create an attribute on there, so when we copy, our template point group will be copied onto these lines as well. Okay, so let's add an attribute create node. Let's create our attribute ID, and let's change the group type to point, and for the first point 0, so here onto the group let's choose the point number 0, and for the 0 the attribute value is 0. Now let's duplicate this node one more time. Let's connect that, and for the point 1 we want to set the ID value to 1. So now when we copy our geometry onto these points, we will have the attribute name ID. Okay, so after the blast, we'll go into the ID, go into the add, and use our ID attribute. Okay, so now we are connecting all of these points correctly. Okay, so let's delete this sweep node, we don't need that, and let's merge both of these curves and these railing curves, merge them, and let me uncheck the display point, set the display flag to merge. So here as you can see, we are creating the railing line onto the wrong side, so we want at the upper side. So let's see where we have the problem. So here onto the top, so the top group is fine, and after the copy to points up, and now it appears to be in inverted, and that is because onto the blast node we are deleting the top node, so we need to check the delete none selected to isolate our top points. Okay, so that was the problem. So let me untemplate my copy to points. Now if we add and see with the merge, so now as you can see we are adding these railing line correctly. So after that let's add a polybar. Let's connect it here onto the polybar parameter. Let's lower the radius down to a small value, and let me uncheck my UV visualization. Let's increase the division for more smoother cylinders, and here as you can see these pieces are not connected, so here we can add a fuse to connect these unconnected points. Okay, so now we are connecting our geometry. Okay, so now let's merge this. Press and hold the Y key on your keyboard to cut the wire, and let's connect this into our stream. Okay, so here we have these railings, and now let's add one big cylinder at the center. So let's create a line. So here we have the line, and here we have the helix. So let's add a match size to create a same size line. So this is the line that I want to resize, and let's use the bounds of the helix. Okay, let's go into the match size and check scale to fit. So now we are using the helix bound to set the scaling of our line. So which means if we change the height, our line height will be adjusted accordingly. So let's add a sweep node to create thickness into our line. Change this to round tube, and let's give him some more columns for more smoother cylindrical shape, and let's add its end caps, single polygon. And here onto the line we can adjust the points to add height segments. Let's merge this with our end results. Okay, so now here we have the center pillar, and here onto the its radius. Let's link this radius with the helix radius, so where it says start radius. So let's copy this parameter. We can say copy parameter, and onto the sweep, onto the radius, select the paste relative reference. So now we are basically referencing our scale. Okay, so whatever the scale we will define here, now this parameter will control this parameter. Okay, so here as you can see, by using the same radius, so we are basically intersecting with our staircase. So let's go on to the spiral node, and down here onto the transform, and here onto the uniform scale. Let's add a uniform scale on top of the start radius. So let's increase its scale until we are happy with the contact scale. Okay, so that is looking good. Okay, so now when we adjust our radius, it will work perfectly. Okay, so here we have the procedural staircase. So we can adjust the number of turns, and we can increase the number of steps by changing the division per turn. Okay, so here as you can see, we have some problems at the end. Okay, to avoid this, let's change the division mode from division per turn to division per curve to create a more consistent. Okay, so now we still have some problems. Here as you can see, when we are using the even number, we have some problems. So if we use the odd number, it working fine. So to fix this, let's go on to the group by range. We can offset this parameter so that when we have the odd number, we can add a 1 at the offset. Okay, so let's go on to the helix, and let me untemplate my group range, and let's copy our division per curve parameter. So right click and say copy parameter, and go on to the group range, and onto the offset let's choose paste relative reference. So now we are basically using the same value as we have onto the division per curve. So to calculate the even or odd, so let's click on the offset and click on the parameter and press the Alt E on your keyboard to make this window bigger. Okay, so after we have evaluated the channel reference, we can say mod So the percentages sign here mean mod, so we can say mod 2, hit apply and accept. Okay, so what it will do, so the modulus will give us the remainder of the after the division. So when we have the odd number, we will have the remainder of 1. So when we have the even number, so let's change this to 140, we will have a remainder of 0. Okay, so let's see if that fixes our problem. So let's set the display flag onto the merge, and it seems that we need the other way around. So what we can do, we can add 1. So first let's add 1 plus this calculation. Okay, so now it should work fine. So if I change the parameter, now we don't have the problems at the end. Okay, so now in the next lesson, let's see how we can create this procedural staircase geometry and turn this into a Houdini digital asset. Okay, now let's see how we can turn this procedural staircase geometry creation tool into a digital asset. Okay, so for that, let's select all of our node. Let's click on this box icon to put every node inside of a single box. So if we dive inside this subnet, so we have all of these nodes that we have created. Okay, so now all of these nodes are packed inside of this subnet. So here we have the parameters. So right now we don't have any parameters in here. So let's click on this gear icon and click on this edit parameter interface. So here we have the parameter interface, and there we have the input 1, 2, 3 and 4 labels. So let's select all of these 4 and click on invisible and hit apply. So we don't have those empty inputs that we don't need. Okay, and now let's promote the parameter that we want to expose. Okay, so for example, we want to expose the height of a staircase as well as the number of turns. Okay, so let's go back onto the subnet, click on this gear and click the edit parameter interface. So here we have the parameter interface. Let me make this window a little smaller. So here we have the root folder. So let's go inside the subnet and let's drag this height parameter onto the root. So here we have the height parameter. So if we go inside and hit apply, so here as you can see we have the height, so which means we can adjust the height from here. And let's select all the parameters that we want to be exposed. So let's expose the turns, and we will also need to expose the radius, and let's expose the divisions. So these are the staircase number of steps. Okay, and let's also expose the uniform scale. Okay, and let's hit apply and accept. So if we go back, so here we have these parameters exposed. We can adjust the scale. We have the divisions and the radius and the turns. So let's rename this parameter to number of steps. Okay, so let's edit parameter interface, and here we have the division. So let's edit its label and change this to steps, apply. So now here, as you can see, we have renamed this parameter to steps. Okay, and into the start radius, let's remove the start and let's type only the radius and apply. So we have the height, turn, radius, steps, as well as the uniform scale. So maybe let's rename this to radius scale. So we're going to the uniform scale. Let's change this to radius scale. Hit apply. So we have the radius scale, and let's expose some other parameters. For example, here we have the distance for the step height. So let's expose this parameter and let's name this to be the steps depth and apply. So we have the steps depth, and let's see what other parameter that we can expose. So onto the sweep, here we have the width for the staircase. So let's expose this parameter as well. So go back, edit parameter interface, let's dive inside and let's expose the width. Let's change this to steps width, steps width, hit apply and accept. So we also have the steps width, and now let's expose the distance of these railings as well. So added parameter interface again, let's dive inside. So we have set this right here when we looped onto these our pieces, and here we have the poly bevel. So this node is responsible for adjusting the distance. So let's add its distance parameter as well. So let's rename this to be rail offset. Hit apply and accept. So here we have the out node, so which means that no matter where we have set the display flag, whenever we go back we will have the output to the very last node. Okay, so let's go back and check the settings. So here we can adjust the railing offset, we can adjust the step width as well as the offset, we can adjust the step depth, and we have the number of steps as well as the radius. Okay, so now let's rename this to be a procedural staircase. So let's select the subnet and go into the asset and click new digital asset from selection. Let's click that. So here we have the option to set the operator name. So let's rename this to procedural staircase with the capital P. Here we have the procedural staircase operator label. So let's make the S capital, and here we have the save to library option, so where you want to save your digital asset. So I'm using my $hip folder, and here we have the procedural staircase.hta. Hit accept. We have another window to set the minimum and maximum inputs. So these are set to 0, so which means we don't have these inputs, we don't need them. Okay, and here you can set the icon. So you can create an icon in a PNG file or JPEG and click on this button and select your icon. Okay, let's hit apply and accept. So now if we hit tab and type our operator name, so here we have the procedural staircase. So this is the digital asset that we have created. Okay, and if you are installing your digital asset into new machine, you can install the digital asset by going to the asset and click the install asset library, and here you can select your HTA file, and where it says install library 2, so here we have selected the current HIP file, so which means whatever the digital asset you select, it will be installed only to the currently Houdini HIP file. Or you can change this to scanned asset library, so it means that whenever you open your Houdini, the asset will be loaded automatically every time. Okay, and press the install button to install the digital asset. Okay, and now let's take a look at another procedural geometry creation example. And for this example, I'm gonna be creating a procedural nuclear reactor chimney. Okay, so let's create a geometry node, dive inside, and let's create a line. Set the line length to 5. And let's add a sweep node to give him thickness. Let's change this to round tube, and let's increase its radius, and let's add some columns for more smoother shape. And let's go back onto the line and add some point to add a height segments. And onto the sweep, let's apply scale along curve, and let's add a point at the middle. And for the middle point, let's bring the scale down just a bit. Let's change this interpolation to B-spline for a more smoother transition. Let's change that for the first point as well. So select the first point and change interpolation to B-spline. And for the last, let's change this to B-spline as well. And here we can adjust the inner radius. We can adjust its position. Okay, and now let's rotate every other ring to create a brick style pattern. So for that we need to group the every other ring. So for that, let's create a group by range. Let's connect that. So we can say select every one of 2. So here, as you can see, our group range sub is not working as we want. Okay, so let's use another technique for that. So let me delete the group by range. So here, when we have created the line and we have these line points, so these points are responsible for adding these height segments. So we can use these line points to group these height segment. So for that, let's add a convert line. So let's connect that. So what the convert line sub will does, so if I set the display flag onto the line and enable my primitive display, so here we have only one primitive 0. If I middle click here, as you can see, we have only one primitive. So when we added a convert line sub, now if we middle click, now we have 14 primitive, and here we have these primitive numbers. So basically at every point, every edges, we are converting these edges to primitive. Okay, so now we have 14 primitive. So now let's add a group by range, and let's connect it here. And now we can say select every one of 2. So now we are skipping every other primitive. Okay, and now let's transfer this group onto this geometry. So we can transfer the group by using a group transfer. So the group transfer works exactly like the attribute transfer, but here we are transferring the group. Okay, so this is the geometry to transfer groups to, and this is the geometry to transfer groups from. Set the display flag to the group transfer. So now here, as you can see, we are selecting every other height ring segments. Okay, so let's rename this group to height rings. Okay, and let's append a transform sub. Connect it here. So let's choose our height rings and let's rotate these rings. So here, as you can see, our rings are not rotating correctly, and that is because currently we have all of this is a one connected piece of geometry. So let's disconnect that. So we can use a facet node, connect it here, and here click on unique points to disconnect every face. So now if we transform and add a rotation, now as you can see, we are creating the brick pattern. So but the problem with the facet and clicking on the unique points is that it is now splitting every individual face. So if I add an exploded view and connect this after the facet, set the display flag onto the facet. So here, as you can see, every primitive are now disconnected, and I don't want that. So what we can do is we can only disconnect these selected primitives, these selected rings. Okay, so we can do this by adding in a node called primitive split node. So here onto the primitive split node, so it requires a name attribute. So if the current primitive has the name attribute greater than the 0, so it will split those primitive. Okay, so let's create a name attribute. So let's add an attribute create sub, and let's set this to be name attribute, and let's initialize it to 0, and let's duplicate this node again, and onto the height rings group, let's set its value to 1. So now if we go into the geometry spreadsheet, so some of the primitives has the value of 1, and some of the primitives will have the value of 0. Okay, so let's connect the primitive split node, set the display flag onto the primitive split, and we are using the name attribute, and we have the name attribute, and the name attribute, it has to be onto the primitive level. So let's change the class from point to primitive. Let's change this to primitive as well. Okay, so now the primitive sub is working correctly. So now if I add an exploded view after the primitive split, and let's change the piece elements from primitive to points. Okay, so now as you can see, our geometry has been sliced up correctly. Okay, so now let's use the transform node and the height rings group, and it should work fine. Okay, so let's add an null at the end, and let's name this to be chimney, and let's add a thickness to our chimney. So let's add a poly extrude node and connect it after the null, and here onto the poly extrude node let's add a distance and change the divide into individual elements to create a brick style, and click on the output back to create the back primitives. Okay, so in the next lesson let's add the railings at the top. Okay, so let's add that in the next lesson. Now let's add the railings at the top of our tower. So here onto the primitive split let's add a connectivity sub and connect the primitive split node into the connectivity node, and let's change the connectivity type to primitive. So if we middle click, we have the attribute called class. So if we go into the geometry spreadsheet and into the primitive attribute, so here we have the class that goes 0 to 13. So let's isolate the very top ring of our tower. Okay, so we note that the very top of our tower ring is the 13, so because that is the maximum number in here at the class attribute. Okay, so let's isolate that. So, and we want to procedurally isolate that because when we change our height segment, so let's say if I increase my height segments, and now if I go into the geometry spreadsheet, and now as you can see we have the 25 individual these primitives and the highest value is the 25. Okay, so let's find a way to procedurally select the very top of our ring. So let's add an attribute promote and connect that, and here onto the attribute promote, so the original class is the primitive. Let's change here on the original name, let's select our class attribute and let's promote this onto the detail level. So now if we go into the geometry spreadsheet, so at the primitive level now we don't have the class attribute, so instead it is promoted onto the detail level, and we have the class attribute and it is set to 13, and because the promotion method is set to average, so let's change this to maximum. So now we are using the maximum number from the connectivity attribute and setting it onto the detail attribute. So let's add another attribute promote because we want this attribute to be onto the primitive level and not on to the detail level. Okay, so let's add an attribute promote and let's connect that, and here onto this attribute promote our original class is the detail, so let's select the class attribute and let's promote it back to the primitive. So now onto the primitive you see we have the value of 25. Okay, and here onto this attribute promote sub, so here it says the delete original, so we are deleting the original geometry. So but we do need the original class attribute to compare. Okay, so here we have the class attribute and onto the primitive level, so when we promoted our attribute onto the detail, so let's change its name, So now let's call this one to an max. So now if we go into the geometry spreadsheet and onto the detail, so now this attribute is called max. Okay, so here onto the attribute promote, and let's select the remove the class and select the max attribute instead. And this time let's check the delete original because we don't need the max attribute onto the detail level. So now we have the attribute called class and a max, and we also have the name attribute from this primitive split section. Okay, so we will clean these attribute later. So now let's add a group expression node, and let's connect the group expression, and here onto the group expression let's name our group to be top ring, and let's use the vex expression. So here we have the attribute name class and a max, so we can say add class. So at the rate of sign and type the attribute name CLASS class. So if this attribute is equal to at the rate of max. Okay, and now the group expression node is throwing an error, and that is because the group name is not correct, so the spaces are not allowed. So let's remove the space and let's add an underscore top underscore ring. So now as you can see, the group expression node is now working correctly. So what we are doing, so we have for the every primitive we have the class attribute. So if we go into the geometry spreadsheet and onto the primitive, so we have the class that is goes 0 to 25. Okay, and we are promoting this attribute onto the detail to calculate the maximum value. Okay, so here we have the max, which is go to 25, and in the group expression node we are comparing these two attributes. So we are saying that at every primitive, so the every primitive has the class attribute, and if the current primitive has the attribute which is equal to the max, which means the 25, so we want these primitive to be in the top ring group. Okay, so now if we go back onto the line and change the number of points, so we will be selecting our top ring group correctly. Okay, so after the let's isolate our top group, let's add a blast node, and onto the blast node let's select our height rings group and choose the delete non-selected to isolate our not the height rings group but the top ring group. So this is the group that we are interested in. Okay, and now let's select the very top edge of our this group. So let's add a group node, and let's disable the base group and go into the include by edges. Let's enable that, and let's enable our max edge angle. Let's enable that, and the group type, let's change this to edges, and let's add the angle to 90 degree. So here as you can see, we are now selecting these inside rings. Okay, we can click on the edge angle uses between edges. So now we are selecting the top as well as the ring. So let's uncheck that, and let's duplicate this group node. Let's connect it here, and in this node let's enable our edge angle. Okay, so let's rename this group to rings, and this group to be rings with top edge. Okay, so basically we have two groups, to edge group, we have the rings group, and we have the rings with the top edges. Okay, so let's add a group combine to add the boolean operation to these groups. Okay, so we can use the group combine node to create the boolean operation for the groups. Let's connect that, and here onto the group combine, let's name this group to be top edge. So now this is the name of the group, and this is equal to the rings with the top edges. Okay, and now let's subtract these inner rings because we don't want them. So let's add a subtraction, and let's subtract with the inner rings. Okay, so now we are subtracting these inner rings, and we have selected the very top edge. Okay, and let's add a poly extrude node to extrude our top edge, and here onto the group, let's select our top edge group. Let's increase its distance. Okay, and now let's delete all of these side faces. So here onto the poly extrude node, let's enable our side group. So we have the extrude side group. So if you middle click, now we have the extrude side group. Okay, so let's delete that, adding in a blast node, and onto the blast, let's select our extrude side group. So now we have the very top extruded faces, and now let's add a polywire to convert these edges into railings. Let's set the display flag onto the polywire, and let's decrease its wire radius, and also add some divisions for more smoother railings. And here onto the poly extrude node, we can add the divisions. So here, as you can see, the divisions are not working, and I think that is because we have made mistake into the blast node. So we are basically deleting these new faces that the poly extrude node has created. So into the blast node, let's click delete non-selected to isolate the top of our faces. Okay, so now here, as you can see, we have these divisions. So if we set the display flag onto the polywire, and here, as you can see, we have these railings. So let's decrease the wire radius down. Okay, let's add a 3 railing lines, and let's add another null at the end, and let's call this one railings, and let's merge it with our chimney. So maybe chimney is not correct name. Let's call this one tower. Okay, and let's merge both of these geometries. So here we have the tower and the railings. So if we go back onto the line and adjust its length or these height segments, we will have a perfectly working setup. Okay, so in the next lesson, let's create the base for our tower. Okay, so let's do that in the next lesson. Now let's create the base for our tower. So here at the connectivity, so here we have the connectivity attribute. So to isolate the very first part of our ring, so let's add a blast node. So here onto the blast node, we can say add class if add class is equal to 0, and let's check delete non-selected to isolate our very first ring. Okay, so because no matter how many we add the length segments, the very first ring will always be the 0. Okay, so we can use the add class is equal to 0. Okay, and now let's add a poly extrude, and let's extrude this space onto the inside. So let's add a negative distance. So this distance is not working correctly, so let's zero it out, and let's go into the spine control, and down here let's change the thickness to lower to create an accurately going inside faces. Okay, so here onto the extrusion, let's enable our side group, and let's add a blast and isolate our these newly created faces. So here onto the blast, select the extrude side group and choose the delete non-selected to isolate these new faces. And here let's select the very bottom part of our base. So let's add another connectivity node to look for the connectivity of these two primitives, these two geometries. Let's change this to primitive, and here let's add another blast node, and in this blast we can say if at class is equal to 1. So now because we only have two connected pieces of geometry, so the first one will have the class attribute of 0 and the bottom one have the 1. Okay, so here we are isolating the class 1. Okay, now let's add a group range, group by range, and select every one of 2, and let's call this group to be a base group. So the group name set to base, and let's add a blast node to isolate our base primitive, and let's select our base group and click the delete non-selected to isolate our base. Okay, so after that let's add a poly extrude node. Let's add the distance to -1, and let's go into the spine control and onto the thickness. Let's lower the thickness. Let's reverse this by adding a reverse node, and after here, so here when we created the base group, let's add another poly extrude node to create a thickness. So let's give him some distance, and let's check output back to create the back faces. And now let's merge both of our geometries. Okay, so here we have the base, and now let's create the base pillars. So let's create a line. Here we have a line. Let's add a transform node, and let's move the line in the X. Okay, now let's add a rotation at the Z, and let's add a mirror node to mirror our these pillars both side. Let's rotate them until they meet, and let's add a sweep node to add a thickness to the sweep. Let's change this to square tube, and also add the single polygon end cap. Okay, so let's go back on the transform. Let's add a little bit of more spacing, and also adjust the width to a lower value. go back to the transform node and let's bring them back again. Okay, so now I want to copy these base pillar at the end of these bases. Okay, so here at the reverse node, when we extruded this our base faces, so let's add another blast to isolate our base faces again. So let's select the base group and choose the delete non-selected to isolate our base group, and let's add the point at the center of our base primitive. So here, as you can see, we have some problems where we have the two primitives selected, and that is because here onto the sweep and onto the columns we have the odd number of columns. So if we change this to 48, now the problem is solved. So here onto this group range, and at the range filter let's add the calculation of the even and odd. Okay, so let's copy the parameter from the sweep. So these are the column. Let's copy this parameter and let's go into the group by range node, and let's select this and say paste relative reference, and here we can say mod 2. Okay, and let's add the 2 at the very first. So 2 plus this calculation. Okay, so now if we go back onto the sweep again, and if we change it back to odd, you see now our problem is gone. So let's go back at the base, and now let's add the point at the center of each primitive. So let's add a node called extract centroid. Let's connect that. So here extract centroid is expecting a name attribute, so currently we don't have the name attribute. So let's change this where it says run over pieces. So let's change this to primitive. So now we are running on at every single primitive. Okay, so if I enable my points, so here as you can see we have the points at the center of our primitive. Okay, so now let's connect these points by adding an add sop. So here onto the add, let's change this to polygon and by group, and let's connect all points and check the close to create a closed circle. Okay, so now let's add a copy to curve to copy these base pillars onto this circle. So let's connect our geometry, and these are our curve, and let's set the display flag on copy to curves. So the orientation is not correct, so let's go into the copy to curve node and onto the additional rotation. Let's apply yaw, and let's apply yaw at the 90 degrees. Okay, let's add a null at the end, and let's call this one to be base pillars, and let's merge it with our rest of our model, and let's set the display flag. So now here as you can see the position of our pillar is not correct. So if I set the display flag onto the copy to curve and template my circle, so here as you can see, so the geometry has been copied at the top of these points, but I want at the bottom. So let's add a match size node, and let's resize this geometry by this circle bounds, and let's set the display flag onto the match size, and let's here onto the justify x, let's change this to none and none. So we don't want the justification on x or z, but only onto the y. So here let's change this to minimum or maximum. Okay, so now we are placing our base geometry at the very bottom. Okay, so now let's connect this into our base pillar null, and now let's view it here at the merge. Okay, so now the offset is still not correct, and that is because we are not including this our base geometry into the scene. So let's connect this into the main merge as well. And now if we see, so here as you can see our base are working correctly. Okay, so if I go back onto the line and if I change my length, and I can change my columns, and here onto the sweep I can adjust the overall radius, I can adjust its scale, and our whole system will work fine. Okay, so here onto the base, let's duplicate this whole base network to create a more detailed structure. Okay, so here we have the base pillars and this is our top base. Let's first merge both of them, adding an merge. Okay, press and hold the Y key on your keyboard and drag to cut the wires, and let's connect this into our null, and here let's add a copy and transform node. Let's connect it here, and here we are creating the two copies, and let's scale these copies down in the X and Z direction. So let's copy this parameter and paste it here as well, paste relative reference. Okay, so whenever I change this will be changed automatically. Okay, so here I can adjust the number of copies. I can also add the rotation. Okay, so now we are creating a more structure. Okay, now if we see it with our geometry, and now let's add a match size at the end as well to make it sit onto the floor. Let's connect it here, and let's change the justification Y to minimum. So now it is perfectly sitting onto the floor. Okay, and at the very last let's create an null and call this one to be nuclear cooling tower. Okay, so in the next lesson let's convert this cooling tower into a digital asset. Okay, so now let's turn this nuclear cooling tower into a Houdini digital asset. So if I middle click on this nuclear cooling tower, here as you can see we have lots of attributes and groups that we don't need. So before the null, let's add a clean sub, connect it here, and onto the clean let's check remove attribute and remove groups. Okay, so now if I middle click, you see now we don't have all of these groups and attributes that we don't need. So now let's select all of our node and click on this subnet icon to make a subnet, and onto the subnet let's click on this gear icon, edit parameter interface, And let's select all of these 4 labels and make them invisible. Hit apply. And let's dive inside the subnet. And first let's create an a length. So let's rename this to height. And let's add its points. Let's call this one to be height segments, and let's add its Y rotation. So here onto the rotation, we only need the rotation Y. So let's select the rotation Y and drag this parameter into here. Now we are only selecting the rotation Y. So let's name this to be rotation, segment rotation, and hit apply. Okay, and let's go into the sweep node, and here we have the columns, and we have the radius, and let's promote the ramp as well. So select the scale ramp and place it here. Okay, and let's see what we can export. So let's hit accept. Let's go back. So here we have the length, we have the height segments, as well as the rotation and the number of columns, radius, okay, and let's also add the number of these railings, inner railings. So let's add the parameter interface and let's dive inside. So we created the railings here onto this poly extrude node. So these are the division. So let's select them and place them here. Hit apply and accept. So let's go back. Okay, so here we have the divisions for the railings. Okay, let's go into the asset and create the new digital asset from selection, and you can name your HTA and hit accept to save out in this location. Okay, so that's pretty much it for this section. Okay, in this section of the course, we are going to learn about Vex. Vex is a Houdini native programming language, and it comes in 2 flavors. Here we have the pure Vex code, and we have the node-based programming. So let's create a geometry node, dive inside, and let's create a sphere. And here let's add an attribute wrangle node. So by using the attribute wrangle node, we can write the pure Vex code. And if you type attribute warp, so here we have the attribute warp node. Double click on this node or press enter to dive inside the node. So now we are in the Vex context. So here we have the nodes for the Vex. So here we can program using the node, and by using the attribute wrangle we can write the pure Vex code. So the attribute warp, when you lay down node to program, so it under the hood write the Vex code. So if I right click on this node and go into the Vex warp option and view Vex code, so here as you can see it is writing the Vex code. Okay, so up until now we are using the attribute create sub to create an attribute. Okay, so here let's see how we can create attribute using the both warps and the Vex. So let's connect the sphere into the attribute warp node, set the display flag onto the attribute warp and dive inside. So here we have these two nodes. So here we have the geometry warp global. So this node is responsible for reading the attributes from the geometry, and this node is for writing the attribute out. Okay, so let's add a node called constant. So here we have the constant node, so you can set the value to whatever you want, and here you can set the data type of your attribute. You can change this to float, integer. Okay, so let's change this to 1. And to write an attribute, we use the node called bind export node, and let's connect the output of this node to the input. And here let's type the attribute name. So let's call the attribute name test. So if we go back and go into the geometry spreadsheet, so here as you can see we have created the attribute test and the value is 1. So if I middle click, here as you can see we have the point attribute test. Okay, so for creating an attribute using Vex code, so let's connect the sphere onto the attribute wrangle node, set the display flag to the wrangle, and here to create an attribute, first you need to define the data type. So if you are writing a float attribute, you can type the F and after that the @ sign. So the @ sign mean attribute, and now the name of the attribute. So let's name the attribute test, and this attribute is equal to 1, and at the end add a semicolon to end your syntax. Okay, so now if I middle click, you see we have created an attribute named test, and onto the geometry spreadsheet here we have the value for the attribute. Okay, and also if you want to create a primitive attribute, so just change from here where it says run over points, change this to primitives. So now if I middle click, now you see we have the primitive attribute, and we can change this to detail, and if I middle click, now we have one detail attribute. And same thing here onto the attribute warp. So the attribute warp is set to run over points. We can change this to primitive. So if I middle click, now we have the primitive attribute. Then change this to detail. Now we have the detail attribute. And if I right click and type warp, so here we have the attribute warp, and we have the point warp, primitive, and vertex warp. So if I lay down a primitive warp, so it's basically an attribute warp, and its setting is set to primitive. Okay, so let's change this back to points. So let's dive inside the attribute warp. So here we have the geometry warp global node to reading the attribute. So here we can read the P for the point position, and V for velocity, and here we have the time, which is in seconds, and we have the current frame number. So let's delete this constant node, and let's connect the time into the output. So now we have the test set to 0. If I open up my play bar and if I play, here as you can see the values are changing. So this is the time, and we can also output the current frame number by using the frame. So if I connect that, so now we are outputting the currently frame that we are in. Okay, so here let's see how we can read the attributes. So if I go into the scene view, and let's say I have created an attribute using the attribute create node. So let's create this attribute test, and let's set its value to 10. Let's connect it here. So if I middle click, we have an attribute named test. So let's go back into the attribute warp. So for reading the attribute, we use the node called bind and here onto the bind node, type the attribute name that you want to read. So I want to read my trust attribute. And now for checking purpose, let's write this attribute out. So let's create a bind export node. Let's connect the output of this node to the bind export, and let's set the name of our output attribute to debug. And now if I middle click here, as you can see, we have the attribute debug as well as the test attribute. So if we go back onto the geometry spreadsheet, here as you can see, the debug and the test attribute have the same value. So that's how you can read your attribute in. Okay. Now let's take a look at geometry manipulation using warps. So let's create a geometry node, dive inside, and let's create a circle. Let's change the orientation to ZX plane. And let's increase the division for a more smoother circle. Let's change the arc type to open arc, and now we can use the arc angle to create a sliced circle. And let's add a sweep to give him a thickness, surface shape to square tube, and let's add the end caps to single polygon. And here let's add an attribute warp node and dive inside. And let's add a transform matrix node, this one. So the transform matrix node is exactly like the transform node. So here we have the transform node, this one. So this node is equivalent to the SOP level transform node. So here we have the position to change. So here onto the geometry warp global, we have the point position. So let's connect that, and let's connect the output of this node to the point position. So now we are reading the current point position, and here onto the transform node, we can translate in the X. So we are setting the X position, and we are writing the position here onto the output. Okay, so let's zero out the translation. So let's rotate this in the axis of Y. So I want to rotate this over time. So here we have the time. So but if we hover over to the time pin, so here as you can see, the time has the data type of float. So if I hover over to the P pin, here we have the point position and its data type is vector. And if I hover over to the PT num, here we have the point number and its data type is the integer. So the rotation has the data type of vector because we have three components. We have X, Y, and Z. And if we connect the time directly into the rotation, so what it will do, it will put the time value at the every axis. So we will be rotating our circle in at every axis at the X, Y, and Z. So if I hit play, here as you can see, we are rotating at every axis. So but I want the rotation to happen only at the y-axis. So we can convert this data type to vector by using a node called float to vector. So here we have the float to vector node. So it has these three inputs. So here we can define the X, Y, and Z, and it will output a vector. So let's connect the vector into the rotation, and here we can set the values for the X and for the Y, for the Z, or we can use the time input. So this is the X and this is the Y. So let's connect that, and let's zero out the X component and the Z component. And now if we play, Here as you can see, our circle is rotating, so but it's rotating slow. So let's add a constant node, and let's multiply this constant with the time to create a faster rotation. So let's add a multiply node. Let's connect that. So here we have the time, and onto the second input let's connect the constant, and onto the constant let's change the value to 10. And now if we hit play, so here we have the circle rotating. So let's increase the speed a bit more. Let's change this to 100. Let's hit play, and let's enable the real-time playback by clicking this clock icon, and now hit play. So the value of 100 is looking good. So let's promote this parameter onto this level, so that we can easily adjust the speed, so we don't have to every time go inside the attribute warp node and change this parameter. So let's delete that and hover over to that input that you want to promote and press the middle mouse button, and here let's choose the promote parameter. So here if I click that and double click to open up its node, so here we are using the parameter node. So if we go back, so here we have the promoted parameter. So let's dive inside, and here let's label this speed, and if we go back, now we have the label set to speed. So here we can adjust the speed. Let's multiply by this by 100, and let's hit play. Okay, let me delete the transform node, and let's duplicate this node, and here let's change the speed to 150, and let's merge both of them by adding a merge node. And after that let's append a transform node and scale this circle down and change the uniform scale to scale it down, and let's hit play. Let's copy this circle one more time. So let's copy the whole setup and merge it, and here onto the transform let's scale it further, and here onto this we have the speed 150, and this one let's change the speed to 200, and let's hit play. So we have the rotating circle at different speeds. At the transform we can add the another rotation on top of that. So let's change their initial position for a more random look, and now let's hit play. Okay, so that's the very basic geometry manipulation by using the warps. So in the next lesson let's take a look at the geometry displacement and remapping values. Okay, now let's talk about geometry displacement with warp. So let's create a sphere node and dive inside, and in here let's add an attribute warp, and let's dive inside the attribute warp node. So for the displacement we want to displace these sphere points. So for the displacement we need the direction, on which direction we want to move these points. So we have the normal. So if I connect the normal into n, and if I enable my point normal, so here as you can see we have these normals pointing outward. So we have a direction vector. Okay, so let's use this direction to move our sphere points. So we can lay down an add node, and let's add the current point position with the normal direction, and let's connect the output to the position. So here, as you can see, our whole sphere has been scaled up. So let me disconnect the normals for now, and let's uncheck the point normal display. So let's add a multiplier to scale down the normal direction length. So let's add a multiply. Let's connect that, and here let's add a constant. Let's connect the constant into the multiplier. So here we have the value of 0. So if I increase this, here as you can see, we are basically scaling down or scaling up our geometry points. So if I see the result as a normal, so if I connect that and enable my point normal display, here as you can see, we are scaling down these vector lengths. Okay, so instead of using the single value, let's use the noise to scale these direction vectors. Okay, so if we type noise, so here we have several different noise type to choose. We have cellular noise, periodic noise, turbulent noise. So let's use the anti-alias noise. So the anti-alias noise requires the point position for the noise sampling. So let's connect that. And if I connect the noise output to CD, and let's disable the point normal display. So here we have the noise displayed as a color. So here let's adjust its frequency, and let's go back and let's add some more points. So let's change this to polygons, and let's increase the frequency to add more points, and dive inside. Let's increase the amplitude a bit, and here as you can see, by adjusting the frequency, we can create a high or low frequency noise. Okay, so let's use this noise as a multiplier. So let's connect that into the multiplier. Let's delete the constant, we don't need that. And now let's see the result. Let's connect this onto the point position. So here as you can see, we are displacing our geometry with the noise. So let's disconnect as a CD and as a normal. And here onto the anti-alias noise, let's make a lower frequency noise, and let's bring down the amplitude. Okay, so that's the basics of geometry displacement. And inside a warp, there is a node called displace along normal. So this node will exactly do this operation. Okay, so it needs the position to displace. So let's connect the point position, and here we have the amount. Let's use the noise as an amount. Let's connect the displace P into our output. Here as you can see, we have the same result. So let's delete this add and multiply, we don't need that. Okay, so let's try another noise. Let's add a turbulent noise. Let's connect the P into the position and the noise output into the amount. So here we have another type of noise, and onto the noise type we have several different noise types to choose. Let's use the simplex noise and increase the frequency, add a roughness. Okay, so let's go back and create a grid. Zoom out a bit, and let's decrease its size, Z size, and let's add rows and column to 100 by 100 to add a lot more geometry into our grid. And let's connect this as a our geometry input and set the display flag to the attribute warp. So here, as you can see, now we are displacing the grid. Let's increase more points. Let's change them to 200. And let's change to smooth shaded. Now let's create a mask attribute to mask out our noise. So we can use the attribute to tell exactly where we want the noise displacement to be applied. So let's add an attribute paint node, and let's connect that, and let's set the display flag onto the attribute paint node. And when the attribute paint node is selected, press enter to have access to its manipulator. So let's increase the brush size. We can increase the brush size. Here is the short key, Control Shift and press and hold the left mouse button and drag your mouse to change the brush size. So Control Shift, press and hold the left mouse button and drag. We are changing the brush size. Let's paint our mask, and if we control click, hold down the control key on our keyboard and left mouse button to draw, now we are erasing our attribute. Okay, let's paint that again. And now let's see how we can use this attribute to mask out our noise. So here onto the attribute paint and onto the attributes, we are painting an attribute named mask. So if I middle click, here as you can see, I have a point attribute named mask. So let's use this attribute. So after the displacement P, let's import our mask attribute by adding a bind node, and we want to import our mask attribute, and let's add a multiply. Let's connect that with the mask. Sorry, we need to connect this at the noise. We want to mask the noise, not the displace P, because now we are setting the point position to 0 and we don't want that. So let's delete it from here, but at the noise, let's add a multiply node again. Let's connect it there and use the mask attribute as a multiplier. So now here as you can see, we are masking out our noise. So which means we can go back, select the attribute paint node and start painting where we want our noise to be applied. Okay, so we can press the control key to erase the mask. Okay, let's create another example. Let's add a grid node and let's change its Z size, and this time I'm gonna use the noise to set up my P scale attribute. So for copying, let's create a box. I want to copy the box onto these grid points. Okay, let's add a node copy to points, and let's copy our boxes into the grid points. Let's scale down the box in the X as well as in the Z and onto the Y axis, something like that. Now let's add an node attribute warp, connect that and dive inside. Let's add a turbulent noise. Let's connect the noise position to position, and let's add a bind export to export our noise as an P scale. So here onto the param, let's change this to P scale. So here now as you can see, we are scaling our boxes down with the noise. We can here adjust the amplitude. We can also adjust the frequency. Okay, so now let's remap the noise output to create the scale of our own. So we can use a node called fit range. So let's connect that. So the fit range need a value, so we want to fit range our noise value, and here we have the source min and source max. So if we go into the turbulent noise and click on this eye icon to bring up the help card. Okay, so currently we are using the alligator noise. So if we click, we have some noise, Perlin, original Perlin. Okay, so here we have the parameter for original Perlin noise, and down here we have the alligator noise. So the alligator noise outputs the value between 0 and 0.5, and the sparse convolution outputs the attributes negative 1.7 to 1.7. So let's use the sparse convolution, this one, and let's remap these value. So we know that the minimum value is the negative 1.7. So the source minimum is the negative 1.7, and the max are 1.7. Okay, so now we are remapping our noise value to 0 and 1, so we can adjust the minimum value. So here I can set the minimum size of our boxes as well as the maximum size of the boxes, and I can change the frequency. Okay, and now let's use a ramp to control the scaling. So for creating the ramp, first we need the value on which side we want the ramp to control our p-scale. So let's dive inside the attribute warp. Let me explain what I mean. So here we have an node called relative to bounding box. So the relative to bounding box require the position. Here we have the position and the node. So which point position? So here we have these inputs 1, 2, 3 if we dive inside, and here we have this pin for these input 1, 2, 3, 4. So let's connect the first input. Okay, so we are using this input and it outputs a vector. So it has 3 components, the x, y and z. Because it's a 2D grid, so the y components will be 0, and we only have the values for the x and the z. So let's convert this vector to float by using a node called vector to float. So here we have the vector, and now we have the x, y, z component separately. So if I connect the x into CD to visualize as an CD, so here as you can see we have the gradient. So the gradient means that where the color is black the values are 0, and here we have the color white, which means their value is 1. So if I write this values to an attribute, let's add a bind export node, and let's connect that and go into the geometry spreadsheet. So here we have the palm. So here as you can see we have these increasing value. So we start with the 0 and we are slowly increasing to 1. Okay, so let's use this as an AP scale. Let's just connect as a CD and delete the bind export, we don't need that. So let's set the display flag to copy to points. Here as you can see we have these increasing values as p scale values. Okay, let's add some more points and let's increase its size. And now let's remap these value with the ramp. So for that let's create a ramp parameters. So here we have the input value. Okay, so the ramp only works with the values ranging 0 to 1. Okay, so we know that this value is 0 to 1. Okay, so its parameters can be adjusted outside. So at the attribute warp, and if we scroll down, here we have the ramp parameter. Okay, let's dive inside and let's change the ramp type from RGB color ramp to spline ramp. So now we can define the spline as a ramp. So if we go back here, as you can see, the ramp is set to 0. So let's give him some values, and here as you can see, we are using the ramp to remap our values. Okay, so let's reverse the ramp by clicking on this icon, reverse domain. So now we have reversed our ramp. Let's reverse it back. Okay, so after that, let's add another fit range node. So here onto the fit range, we know the, let's connect that, it's not connected, now it is connected. So we know that the source minimum values are 0 and max is 1. So we can remap this with the fit range. So let's say I want my minimum value to be 2 and the maximum values to 3. And now let's go back onto the box and let's scale it down to 1 by 1, or maybe let's scale it even more down. Okay, we have a very small scale of box. So we can go back onto the attribute warp and adjust the scaling with the ramp. So let's dive inside the attribute warp here onto the fit range. Let's change the destination min to 1 and max to 2. So here, which means that the minimum size of our box will be 1 and maximum will be 2, and we can also increase the maximum. So the maximum now will be 4 and the minimum value will be 1. So if I go back onto the ramp parameter and let's delete these knobs. So here as you can see, I have the value set to 0. So even though I have set the value to 0, our box scale is not 0 but as an 1, because we are remapping with the fit range node. Okay, we can also adjust our minimum to our liking and adjust the ramp parameter position. Okay, so that's the basics of working with noise and remapping the values here inside of attribute warp. Now let's talk about importing the attributes into warps. So let's add a grid and dive inside, and let's lay down an attribute warp node. Okay, so we know that we can use the bind node and type the name of the attribute to import the attribute inside of warp. So what if we have another geometry? So let's say I want to create a sphere, and let's change the sphere polygon primitive type to primitive. So it means that now if I middle click, the sphere has only one point. Okay, so let's say if I want to import attributes from this geometry into the attribute warp, so how we go about that? So let's create an attribute. Let's create a color attribute, and let's color this red. And now I want to import this red color into the warp. So let's connect this into the second input of attribute warp, and let's dive inside, and in here let's add a node called import point attribute. So if you want to import point, choose the point detail primitive. Okay, so the CD I have created on the point level, and I want to import my point attribute. So let's click on this import point attribute node, and the import point attribute node, here you can specify which attribute that you want to import. I want to import my CD, so capital C lowercase t CD, and it requires from which input here onto the file. So here we have these inputs, so let's connect the second input. Okay, so this out input 2 mean this input, this second input. Okay, and it also need the ptnum, the point number from which point that you want to import. So here if I middle click, because I only have one point, so here onto the ptnum, click the middle mouse button at this pin and add a constant node to create a constant node. And now if I connect the result into CD, now here as you can see we are importing CD attribute. So here onto the ptnum, if I change my point number, here as you can see the attribute has gone black, which means 0. So because currently we don't have any more points more than 1. Okay, so that is why it's gone black. So let's change this to 0. Okay, so let's take a look at how we can import this attribute based on where our geometry is located relative to the grid position. Okay, so for that we have a node called point cloud open. So if you type PC open, so this is the last one, point cloud open. So here we have the node, and it also requires the file. So I want to import from the second input, and it will output a handle. So we have to add a node called PC filter, point cloud filter, this one. So it has the input type of handle. So let's connect this handle to the PC filter handle, and here onto the filter we can specify which attribute that we want to import. So we want to import the CD. Let's type the attribute, and now let's connect its result into the CD, and it also requires the position for sampling. Okay, so if I connect the position into the sampling position, now as you can see we have the attribute gone black, which means 0. So if we go into the PC open and increase the search radius, okay, if I increase the search radius to 1, now as you can see we have the attribute based on where our sphere is located. Okay, so here onto the grid, let's increase the rows and columns to add more division. Okay, so now if we change the radius, now it is working, because now we have a lot more points to sample. Okay, so if I change my sphere position, here as you can see now we are importing the attribute based on the location. Okay, and if I move my sphere up, okay, and if I want to import the attribute from at this distance, I need to go back and increase the search radius to a higher value. Okay, so now we are giving more radius to search for the attributes. So this node is the equivalent to the SOP level attribute transfer node. So if I create an attribute transfer, this node, okay, so basically we are creating this node on our own inside of the attribute WAP. Okay, So that's how you can import attributes into the attribute warp. Now let's talk about attribute wrangle node to write our pure vex code. So let's create a sphere and dive inside, and in here let's add an attribute wrangle node, and let's bring up its parameter. Okay, so here we can write our vex code. So let's see how we can create the attribute. So if you want to create an attribute integer, so let me explain the different data types. So here we have these integer. So the integers are the whole number without the decimal, so which mean 1, 2, 5, 7. So these are the integer number. And we also have the data type float. So 1.3 or 7.5. Okay, so these are the data type of float, and we also have the data type string. So let's say if I want to write a name, so for example the box or hello world, so this is a data type of string. Okay, and we also have a data type vector. So for example the point position, so where we have these three values, we have the value for x, we have the value for y and z. So this is the data type is vector. So the point position is a vector, and the attribute cd, which means color diffuse, so the color have three values. We have one value for R, for red, we have one value for green, and for blue. So because it has three values, so which means the cd is also a vector. Okay, and there is also another data types. These are the attribute data types that you will be using most of the time. Okay, so let me close that. So if you want to write an attribute integer, so you have to type I, so I mean integer, and after that type the @ which means I'm creating an attribute. And now the attribute name, let's name our attribute debug, and after that the equal sign to set the value. So let's say I want to set the value of 5, and to terminate your argument you need to add a semicolon at the end. Okay, so now I have created an attribute named debug. If I middle click, and sure enough I have an attribute named debug, and it is an integer. So if you type the f here, if I type an f, so now it means that I am creating a float attribute. So now if I middle click, debug as a float attribute, and the semicolon is necessary. So if I remove the semicolon, now as you can see the wrangle node is throwing an error. So we have a syntax error. So you must add a semicolon to terminate the argument. Okay, so for writing string, let's type s @ for the attribute. Let's name this attribute name, and to create the string, the syntax is for that is create a double quote sign, and here you type the string that you want to create. So for example, let's say I want to name this sphere and end it with the quotation mark, and at the semicolon at the end to end the argument. So now if I middle click, now you see I have an attribute name, and it's a string. So if I go into the geometry spreadsheet, here as you can see I have the name attribute, and there we have the sphere. So I can rename this to box. Here as you can see we have created an attribute box. So let's see how we can create a vector attribute. So for vector, you need to type v, which means vector, and the @ sign. So let's say I want to create a color attribute. So capital C, lowercase t, CD, and let's set its value. To set its value, you need the curly braces, and in here type the value for the first component. Let's say I want to create the red color, so let's set the red to 1 and 0 out the Y for the green and 0 out the blue. Let's end this with the curly braces. So you need to type your vector component inside of these braces, and at the end semicolon to terminate your argument. So here as you can see, now we are creating a red color sphere. So I can change this red to 0 and the green to 1. Now we have a green sphere. I can 0 out, and for the blue set this to 1. Now I have a blue sphere. Okay, and inside of your Vex program you can create these channel. So let's say I want to set my colors using these parameter. So I can say after the CD, let's here create a variable. If I want to create vector variable, you need to type the full name of the variable. Let's say vector, and here the variable name. Let's say I want to name this color, and this one equal to, let's create a red value, the X to 1 and the green to 0 and the blue to 0 as well. And let's end this. So what the variable is, so we have created a color variable, so that this variable is only accessible inside of this wrangle node. So which means that the data of this variable will not be exported. So if I middle click, you see currently I don't have any variable that is a color. So variable is only used inside of this program. So here onto the CD where I am setting the values, I can reference this variable. So let's say v at CD is equal to color. So let's type the name of our variable. Now as you can see, we are creating a red color. So here I can change the data from this variable. Let's say I want to create a green. So let's set the color variable green to 1. Okay, so that is a variable. So you can create a float variable, type float. So here we have the variable type and now the variable name. So let's say I want to create a name f, and this one equal to 1. Okay, now we have created a float variable, and same thing with the integer, type int. So here we have the data type of int of this variable, and I'm gonna call this integer. Let's set its value to 10. Okay, so these are the variables and these are the attributes. Okay, so let's create a parameter for our color. So let me delete this float variable and the integer. Let's remove these attributes, we don't need them. Okay, to create a parameter, so we need to type the function called ch. So here we have the chv for the vector channel. Okay, and here you type the name of your parameter. So let's say I want to create a parameter name color. So let's type the color. So it is a string, so the name must be written in the string. So I have the quotation mark at the start, and now at the end let's add another quotation mark. Okay, here we have created a channel vector and we set its name, and its name set in these brackets, and if you click on this create parameter button to create a parameter, so here we have the vector parameter and its name is set to color. So here I want, if I set the red one, now I'm creating the red color sphere, and I can set this to green. Okay, so that's how you can create the parameter. And if you want to create a float parameter, so let's store this inside of a variable named test, and here let's create a channel float by typing CHF, which means the channel float. And now let's create this small bracket and type the parameter name. So let's name this debug and quotation mark and end the small bracket, and at last add a semicolon to end the argument. And now let's click on this parameter button to create a parameter. Now we have the parameter debug. Okay, so we can create an attribute to check if this value is working. So let's store this variable into an attribute. So the data type is the float. Let's type f and at the rate of sign, and here let's name our attribute test, and it is equal to our variable name test. And at the end let's add a semicolon. So if I middle click, now you see I have a test attribute. If I go into the geometry spreadsheet, here as you can see I have an attribute named test, and its value can be adjusted from this parameter. So if I change this, here as you can see I am changing my attribute value. Okay, let's create a little example. Okay, so for that let's create a helix. So here we have the helix. Let's increase its height and decrease the number of turns, and here let's output our orient attribute for the orientation, and let's create a test geometry rubber toy, and let's use the copy to points to copy onto these helix points. Okay, and here onto the helix let's decrease the number of points, and let's increase its height and also create some more turns. Let's increase the radius as well, and let's increase the number of points. Okay, so after that let's add a resample node. So we can use the resample node to resample the curve points by changing this length slider. So for this I don't want to adjust the number of points of our curve, so let's uncheck that. So instead I want the curve view attribute, so let's check the curve view attribute. So if I middle click, here as you can see I have an attribute named curve view. So if I visualize this attribute, let's click this eye icon and click on this curve view. So here as you can see we are visualizing the curve view as a color. So let's change that. So if you come here we have the visualizers, right click, and here we have the curve view. Click on this pencil icon to edit the visualizer. So the type is set to color. Let's change this to marker. So now we are visualizing our attribute as a text. Okay, so at the point 0 we have the value of 0 for the curve view, and it is slowly increasing all the way to 1 at the end. So basically we have an increasing value from 0 to 1. Its range is 0 to 1. Okay, so let me disable the curve view visualization. So let's use this curve view to set our p scale. So here let's add an attribute triangle node, connect it here. So here I can create an attribute p scale. So the p scale is a float attribute. So let's type f for float at the rate of, now the attribute name p scale, and I want this to be equal to the curve view. So @ sign for reading the attribute. So the attribute is called curve view, and now let's add the semicolon at the end to end our argument. And now let's set the display flag on copy to points. So here, as you can see, we have an increasing scale. Okay, now let's remap this curve view value with the ramp parameter. So to remap this with the ramp parameter, we have a function called channel ramp. So if you type ch and the ramp, so here we have the channel ramp. So let's open bracket, and here we need to type the parameter name. So it's a string, so let's add a double quotation mark, and let's call this one scale. Let's end this with the end quotation, and after that it needs the attribute to remap, and I want the curve view attribute to be remapped. So here at curve view. Okay, and let's end this with the semicolon, and now our rubber toe is gone because the scale is set to 0. Let's click on this parameter button to create the ramp parameter. Okay, so here we have the ramp parameter to adjust. Okay, so now we are using the ramp to adjust our p scale value. Okay, we can also fit range this. Okay, so first let's store this our ramp scale into a variable. So here let's change this to a variable by typing the data type for the variable. So let's change this to float, and now let's name this variable to remapped. Okay, so here we have the remapped value of our curve view, and now let's here create an p scale f at p scale, and let's say this one is equal, set the range. We use the function called fit. So here we have the several different functions. So we have the fit 01, fit 10, and fit 11. So the first one, fit 1, mean that here if I go back onto the usage, here we can define the value that we want to remap, name of the value, and after that we can specify the minimum input range, maximum input range, and after that the output minimum and the output max range. So if we know that the value is 0 and 1, so we know that the channel ramp outputs the values between 0 and 1, so we can use the function fit01. Okay, because we know that the value will always be between 0 and 1. So let's name the value that we want to remap. So I want to remap my remapped value. So let's type our variable name remapped, and here we can specify the output minimum. Let's say I want to in minimum p scale of 1 and the maximum p scale of 2. And now let's end this and add a semicolon to end our argument. Okay, so now if I set the ramp parameter here to 0, here as you can see our minimum scale is always 1, so I can change this. So let's say I want the minimum scale to 0.2 and the maximum scale to 1. Okay, so Here we are remapping our value, and you can also create a parameter to specify your min and max. So instead of typing the values manually, let's create a parameter. So for that, let's create a CHF for the float parameter, channel F, and let's name this parameter to min. Okay, and for the max, let's create a channel float, and let's name this max. Okay, so let's add a spaces in between for better understanding. Okay, and let's click this parameter to generate your min and max parameter. So now here we can use this parameter to define our min and max scale. Okay, so that's how you can remap your values by writing your own Vex code. Okay, now let's create our very first geometry projection deformer in both Vex and Warps. So first we will create our deformer with Warps, and then we will see how we can create the same deformer with Vex. So let's create a geometry node and dive inside, and in here let's add a test geometry crag, and let's add a line. Let's template our line, and let's change its X position. Okay, so what I want is I want to project this line onto the legs of the crags and have the line follow the animation of our crag. Okay, so into the line let's add an attribute warp node. Let's connect the line to the first and the crag to the second input, and let's dive inside the attribute warp. So here we have a node called XYZ distance node. So we want to look for the distance of our line from the crag. So that's the second input. So let's connect this into the input, and we want the current point position distance, and this node will gives us three informations. So here we have the distance, so that will tell us that how far away our line is from this geometry. Okay, and also it will tell us the primitive number. So if I set the display flag onto the crag, and right now our crag is a packed geometry, so let's unpack it. Okay, and let's hide the UV visualization, and if I enable my primitive number, so here as you can see we have these primitives. Okay, so this primitive pin will give us the information is which primitive is the closest to our line point. Okay, and also the prim UV position. So if we take a look at the one primitive, so here we have the primitive number, and each primitive has their own intrinsic UV position. Okay, so these are what called the pericentric coordinates. Okay, so it will give us the primitive number as well as the closest prim UV position. Okay, so let's disable the primitive number display, and let's delete the unpack to create an packed geometry for faster preview. And let's dive inside, and here we can use the node called prim UV primitive attribute. So here we have the primitive attribute node, so it requires the file, so which file that you want to import the attribute. So let's connect the second input, and it needs the primitive number from which primitive that you want to import the attribute from. So here we have the primitive information with this XY twist node. So let's connect that. And also it needs the primitive UV position. So we also have the prim UV information from the XY distance node. So let's connect that. And at the prim UV, you can specify which attribute that you want to import. So let's say if I want to import the normals, so if I type the N, okay, and if we middle click here, currently we don't have normals. So let's unpack our geometry again, and if I middle click here, as you can see, we have a vertex attribute normal. So let's create a normal node to add normals, connect it here, and let's change the add normals to points. And now if we middle click, now we have the N attribute to the point. So if I enable my point normal display, so these are the normals of our geometry. Okay, so let's go back inside the attribute warp and let me untemplate my crag, and let's say I want to import the normal. So let's connect this into our N. So here, as you can see, we are importing the normals. So let's give some more points, and if I enable that and template my line, okay, so whichever primitive is the closest to our line points, it will give us the normal. So at the currently closest points normal, okay, so we are transferring the normals from this geometry to our line. So but I want the position information, so let's change this to P for position, and let's connect this into our P. Okay, so immediately, as you can see, we are projecting our line at the crag legs. So let's decrease the distance. Okay, so as you can see now, because we are bringing our line closer to the crag, so maybe let's add a polywire for better visualization. Okay, and let's template the crag. Let's decrease the wire radius, give some divisions. Let's uncheck the point and the normal display. So here, as you can see, we are projecting our line onto our crag legs. Okay, so if I hit play here, as you can see, our deformer is now breaking, because if I open up my play bar, so here at the first frame we have these primitive closest to our line. So when our crag is changing its position, so then these points are no longer closest to them. So that is why we have this breaking geometry. So to fix this, let's delete the unpack and the normal, we don't need them. Let's add a time shift node, connect it here, and at the time shift onto the frame, right click and click delete channel to create a still frame. So now we don't have the animation, we have the still frame. Okay, so let's use this still frame to get the information of our closest primitive number and the prim UV. Okay, and let's delete the prim UV here and remove our position input, and let's store this into an attribute by using a bind export node. and this one, let's call this one prim, and let's connect the prim input to store our primitive number information. And let's add another bind export node, and let's call this one prim uv to store the primitive uv position. Okay, so now if we go back and middle click, now you see we have two attributes. We have prim integer and the prim uv. Okay, so we are collecting the information with the xyz distance node and storing it. Okay, and after that, let's add another attribute warp node, and let's connect our original animated crag into our second input. Okay, and dive inside, and here let's add a prim uv primitive attribute, and we want to import from the second input. And for the prim, let's use our bind node to import our prim attribute, and it is an integer attribute, so let's change the type to integer. And let's add another bind node, and this time import our prim uv, and this is a vector attribute, so change this to vector. And let's connect the prim to the primitive and the uv to the prim uv. And here let's import our p for position, and now let's use this into our point position, and let's set the display flag to the polyvar. Okay, and now if I hit play, let's merge this with our crag. Let's add an merge node, connect the polyvar and the merge, set the display flag to merge, and let's enable the real-time playback by clicking the clock icon. And now if I play, here as you can see, we have our geometry following the animation correctly. We are sticking our line to the crag legs. Okay, so basically we are collecting the attribute from the single frame, so that's the single frame without the animation. Here we have the line. Okay, and using the xyz distance node, we are collecting the primitive number and the primitive uv position and storing them in an attribute. And after that, we are using the prim uv to import our point position from the animated geometry, and the primitive number and prim uv is not changing because we are collecting this information from a single frame. Okay, and here as you can see, we have a perfectly working projected geometry deformer. Okay, so let's see how we can build this deformer in Vex. Okay, now let's create our deformer with the Vex code. Okay, so let's select all of these nodes and create a network box by clicking this icon, and let's rename this to be deformer with warp. Okay, and here let's select all of these nodes and duplicate them here. Okay, and in here let's remove the attribute warp, and instead let's add an attribute wrangle node. So this is our geometry, this is our still frame crag. Okay, non-animated crag, and in here let's collect our closest primitive number and the prim uv position. Okay, so for that let's use the function called xyz twist node, xyz twist function. Okay, let's open its bracket, and if you click on this function and press F1 to bring up the help of the current vex function. So here as you can see we have the xyz twist vex function. So there are several ways we can call this function. So here we have the return type float, so which means it will give us the distance. Okay, and it needs the geometry and the origin, which mean the positions to sample. And also you can store the integer prim number and the uv. Okay, so here at the sign mean that this node can output multiple information. Okay, so the first, it has the return type of float, which means the by default it will return the distance, and it also can output the primitive number and the vector uv position. Okay, so here let's type float twist. Okay, so because the distance is a float attribute and the return type is float. Okay, and for storing the primitive number and the primitive uv, let's create a variable. So the primitive number is an integer, so let's type int, and let's call this variable prim, and let's add the semicolon. Okay, so we are initializing the prim integer variable, but the value is empty here. Okay, because we are not assigning anything. And also let's create a vector uv, so let's add vector, let's call this one uv, and let's add the semicolon to initialize our uv variable. Okay, so now currently these two variables are empty, so let's use the xyz distance node to store the information into this variable. So first it needs the geometry, so we want the geometry from the second input. So here we can type 1, so the 0 mean first input and the 1 mean the second input. And after that the origin for the sampling position, so we want at the current line point position, so we can say at p, which means the currently processing point position. And after that the variable name to store the primitive number, so we have created a variable name prim, so let's use this prim. And for the prim uv, we have created a variable uv, so let's type uv here, and let's close with the bracket and add a semicolon. Okay, so here we have a syntax error because we are creating a float distance and we need to add an equal sign. Okay, so now we are working correctly. So here we are storing the prim and the prim uv into a variable. So but for to access into the another wrangle, we need an attribute. So if I middle click, so currently we don't have an attribute, so instead of creating a variable, let's create an attribute. So by saying I add sign, and after the vector v add sign, and now here we have the syntax error again because now it is looking for variable, so currently we don't have variable. So to store into an attribute, you must add an add size, so it means that attribute. Okay, add sign here. So now this node is working correctly, and if we middle click, now we have the prim and the uv position. So if we go into the geometry spreadsheet, here as you can see we have the primitive numbers and the uv positions. Okay, and after that let's add another angle, and let's disconnect it here, this one, and the animated crack to this one. And here let's add our function name prim uv, and click on this prim uv and press F1 to open the help for this function. So we have the prim uv vex function and interpolates the value of an attribute at certain parametric UV position. Okay, so here we have the return type. So type that which attribute that you want to import. So if you are importing the P, so the return type will be a vector. Okay, so let's say at P is equal to prim UV. So here it needs the geometry. So 1, which means the second input. Okay, and the attribute name, and its syntax is string, so which means we need to add this into this column. So I want to import the P for the position. Let's end this with semicolon again, and it needs the prim num. So we have created an attribute named prim, so let's use this attribute by adding an @ sign and typing the attribute name and the prim UV position. So here we have the attribute name UV. Let's end this, add a semicolon. Okay, so now this green line means that this will work, but we have the costing error. So it means that at prim we need to define that which type of this attribute is. So if I type I, so now it knows that it's an integer attribute. And here we have the V, so let's type V at UV, which means this one is a vector, and now we don't have those errors. Okay, and now if I set the display flag onto the merge, let's play back our animation. Here, as you can see, we are creating the same deformer with the vex code. Okay, so if you open up the help card, go to the help and to the contents, and down here onto the vex, and scroll down. Here we have the reference to the vex functions. So here we have all of the different types of vex function that we can use to write our vex code. Okay, and you can also filter them with the tags. So for example, if you want functions related to the math, so here we have this category for math. So now here we have these functions related to the math, and also for the arrays and attribute, and for the conversion. Okay, so if you click on the any function, so it will bring up the help for this function. Here we have the cos function, return the cosine of the argument, and here we have the return type name float and the vex function, and here it needs the data type, this function, to work. Okay, so you can use this help to learn more about all of these vex function. Okay, now let's talk about volumes. So let's dive inside our geometry node, and in here let's add a torus. Set the display flag to the torus, and let me enable my lighting by clicking on this normal lighting. So we have the shading correct. So let's increase the radius. Okay, and here let's add him some columns for a more smoother torus. And right now if I middle click, here you see we have a geometry that is made out of points, primitives and polygons. Okay, so to convert this our geometry into volume, we have a node called VDB from polygons, because our input is a polygon. Okay, so let's connect that and set the display flag to the VDB from polygon node. Okay, so here we are generating a distance VDB. Let's uncheck that and let's enable the fog VDB. And for better visualization, let's bring up the display option by clicking on this I button and go into the background and change the color scheme to dark. Okay, so here we have the fog volume. So now if I middle click, now you see we have a 1 VDB volume and its name is set to density, and here we have its voxel size. We can adjust its voxel size here where it says voxel size. Okay, and in Houdini we have two types of volume. We have the VDB volumes and we have the Houdini volumes. To create Houdini volumes, you can type ISO offset and let's connect the geometry, set the display flag to the ISO offset node. Okay, and now we are creating a Houdini volume. So if I middle click here, as you can see, we have 1 volumes, which means it's a Houdini volume, and here onto the VDB we have 1 VDB. Okay, to adjust the quality of our volume, we can adjust the voxel size. So here the voxel size is set to the max axis. So let's change this to by size. Now we are individually setting the size of our voxel. Okay, so first let's talk about what is actually a voxel. Okay, so here I have created an example. So we have let's go into the top view and let's disable the lighting. Okay, and in here, as you can see, we have an image of a leaf. Okay, and image is made out of pixels. Okay, so if you decrease the number of pixels, we have a more blocky image. Okay, and if you increase the number of pixel, you will get a smaller pixel size and a sharper image. Okay, so these are the pixels, and same way the voxel works same way. So here we have the voxels. So these are what we called a 3D pixels. Okay, we can visualize these voxels. So if we are working with the VDB volumes, we can say VDB visualize tree. So let's connect that. So here, as you can see, these boxes are what called the voxels. So we have these 3D pixels. Okay, we can set these pixel size by changing the voxel size. So the currently voxel size is set to 0.1. So let's change this to 0.01. Okay, so here, as you can see, we have a lot more smaller and more voxels, and as a result we have a very clean and sharper volume. Okay, and we have these two types of volume, the VDB volumes and the Houdini native volume. So the difference between the Houdini volumes and the VDB volume is that the VDB volumes are more efficient because they are sparse. So if I visualize the voxels here, as you can see, we are adding voxels only where our geometry is present, and we are not wasting inside or outside to add more voxels. Okay, but if we visualize our Houdini volumes voxel, so for visualizing the voxels for Houdini volume, we don't have a node. So let's create this VDB visualize tree on our own. So here let's add a volume warp. So this node is exactly the same as the attribute warp. So but here we are working with the volumes because that is why we have a volume warp, and it is throwing an error. So it cannot find the primitive attribute name. So here onto the ISO offset, let's name our volume. So let's name this to be intensity. Okay, now as you can see, the volume warp is working fine. So let's dive inside. So here we have the volume warp, and this P position means the currently voxel position. So let's add a point at the current voxel position. So the add point requires a position to add a point. Okay, so let's connect the current voxel position into the position node. So here as you can see, we have the voxels visualized in points. So let's create a box. And let's add a convert to line to convert this box into lines. Okay, and here onto the size we have the uniform scale. So let's copy our voxel size as a box size. So let's copy this parameter and onto the box, onto the uniform scale, paste relative reference. So now we are controlling the size of the box with the voxel size. So we know exactly the size of our voxel. Okay, so let's copy this point, copy these boxes to these points, copy to points, and let's connect the geometry into these points. Okay, so now here as you can see, we have these voxels visualized. So here as you can see, the Houdini volumes are using the entire bounding box of our geometry. Okay, to add a voxel. So here onto the VDB we are discarding the inside voxel, so we are only adding voxel where we have the geometry. So VDBs are sparse and they are more efficient. Okay, and we can check if we have built our visualizer correctly. So if I bring the visualize tree aside, here we have the volume, and let's duplicate this volume warp and connect it here. Okay, so here as you can see, we have added the points, and let's connect this into copy to points. Okay, so here as you can see, we have basically built our VDB visualizer tree. Okay, so we can confirm that our this setup is working fine. Okay, so there you have it, these two types of volumes. Okay, now let's take a look at the STF volumes. So let's create a geometry node and dive inside, and in here let's add a test geometry pig head, and now let's convert this into volume. So let's use the VDB from polygons node, and here as you can see, we are creating a distance VDB. So it is called the STF, which means the sign distance field. Okay, so let's lower down the voxel size to add more voxels to our pig head. Okay, and so basically what the sign distance field is, it's storing the values. So at the outside, at the surface of our geometry, we have the STF value of 0, and as we go outside of our surface, we have the positive values, and if we are inside of the surface, we have the negative values. Okay, so let's check. Add an add node, add a point at the center. Okay, and in here let's add an attribute warp node. Let's connect the add and the STF volume into the second input of our attribute warp, and let's dive inside. To import the STF values, we have a node called volume sample. Connect that, and here it requires the file, so we have the second input and the sample position. We want to use our current point position as a sample position, and now it will output the STF values. So let's store them by adding a bind export node, and let's create an attribute STF. And if we go into the geometry spreadsheet, here as you can see we have the STF value and it is in negative. So let's visualize this. Click on this I button and click on the STF. So now we are visualizing as a color. So let's go into the visualizer and onto the STF, click on this pencil button and change the type from color to marker. So here as you can see we have a value of negative 0.03, which means we are inside of our geometry. Okay, if I add a transform node, press enter on the viewport to access its manipulator. So here as you can see, as I move up, so now we have the positive value, so which means that we are now outside of our surface, and at the surface we have an STF value of 0. So it has a sign. So if you go inside we have the negative sign, and outside we have the positive value, so that is why it is called the sign distance field. Okay, so you can use the sign distance field to detect if your geometry is inside of another geometry. Okay, and if we go into the VDB from polygon and add a visualize VDB visualize tree. Okay, so here we have these voxels. So if we move our point outside of these voxel, so we will have a last value. Okay, so now if I move my point, our values are not changing. Okay, so you need more voxel for more information. So here onto the VDB from polygon, let's increase the exterior band voxel to add some paddings. Okay, so now we are adding padding. So if we go into the transform node, and here as you can see now we have the values changing because we added more voxels. Okay, so you can also use the sign distance field to create organic shapes. Okay, so let's take a look at the basic Boolean operation. So let's add a sphere, and let's change this to VDB from polygon to convert this into an STF volume. Okay, and let's add a VDB combine node. Let's connect this one to our VDB A and this one to VDB B, and here we have the operation set to copy. So let's change this to STF difference. Okay, and let's add a transform node and move our sphere. Okay, here as you can see we are creating the Boolean operation with the volumes. Okay, and after that you can lay down VDB convert node, and using the VDB convert node you can convert this to Houdini volumes. So here we have the convert to volume. So if I middle click, now you see we are converting it to Houdini volumes, and you can also change this to polygons. So now we are converting back our model to polygons, and here you can add the adaptivity to add more divisions where we have details. Okay, so let's create another example. Let's add another sphere. Let's change this to VDB by adding VDB from polygons node, and onto our original sphere let's scatter some points. Let's uncheck relax iteration and decrease the number of points. Let's copy smaller sphere onto these points. Let's add a copy to points node to copy our sphere to these points, and let's decrease the uniform scale down. Okay, now let's convert them into VDB by adding VDB from polygons. So let's decrease the voxel size to add more voxel because we have smaller sphere. Let's change this to 0.001, and now let's add a VDB combine node, and this is our VDB A, this is our VDB B, and onto the operation here we have the STF union. So let's change its voxel size to lower, add a more voxel because we have the smaller spheres. Okay, .005. Okay, so that voxel size is looking good. And after that let's add a VDB smooth STF node, and to smooth out our VDB let's connect that. Okay, and here as you can see we are creating an organic bubbles onto our sphere, and let's add a convert VDB to convert our VDB to polygons. Change this to polygons, and let's enable the smooth shaded. Okay, and here you can increase the number of iteration. And let's increase the filter voxel radius, and let's also increase the uniform scale to 0.1 maybe. Okay, and let's randomize our scale by adding an attribute randomize node, and let's randomize our p scale. So right now our calculation is slow, so let's go into the VDB from polygon and let's increase the voxel size to add less voxels for faster calculations. And at the attribute randomize, let's randomize our p scale value, and VDB smooth, let's decrease the filter voxel radius. Okay, and let's change this to STF difference to subtract our BVDBs. So now we are punching holes. And onto the attribute randomize, let's change the distribution to exponential. Okay, let's increase our main sphere size to 1.5. And here as you can see we are creating a meteor like structure, and let's smooth out our VDB to create a more smoother look. Okay, let's increase this to 0.7 to add less voxels for increased speed, or maybe let's change this to 0.1, and let's increase our radius to 2. Let's scatter some more point by increasing the force total count. Okay, and you can always change the shape here. So let's add a box. Let's connect this into our AVDB, and let's use this as a scatter. So let's scatter the spheres onto our box. Okay, and let's decrease the uniform scale to a lower value, and let's also disable the VDB smooth node. Okay, now we are punching holes onto our box, and you can also add noise to your VDB by using a node called volume noise STF. So let's connect that after the VDB combine node. So the volume noise STF is basically a mountain saw that we have, this one. So this mountain saw works at the polygons. So if I create a sphere and connect it to the mountain node, let's change this to a polygon, increase the frequency to add more divisions. Okay, and here as you can see, this mountain saw is adding the noise to the polygons, and this is the exact same mountain node, but this one is designed to work for the volumes. Okay, so here we can adjust the element size to create a high frequency noise. We can adjust the amplitude. Okay, so we have lots more interesting shapes, and also we can enable the blend to blend our noise to original STF. You can, and we are using the constant value for blend. You can also use the mask volume to direct where your noise you want to be applied. Okay, so let's create another example. Let's add a tube node. Let's add its end caps. Let's increase the height to 2, and if we enable wireframe, let's add some rows and columns to add more geometry. Okay, and after that let's add an attribute paint node, and when the attribute paint node is selected, hover over to the viewport, press enter to access its manipulator, and let's paint our mask. Okay, so here we have our mask, and let's use VDB from polygons again. So here we are converting it to STF. So if we middle click, we have one volume named surface. Here you can set your name of your VDB. So to import our mask, let's click onto the surface attribute plus button, and here attribute, let's choose our point mask. Okay, so now if you middle click, now we have two VDBs. We have a surface and a mask. Okay, let's lower the voxel size to 0.02 maybe, and let's add a volume noise STF. Let's change the noise type to fast to create a fast noise. Let's decrease the element size and increase the amplitude, and let's turn on our blend and use our volume. So here already we are using a volume name mask. Okay, So here, as you can see, we are limiting the noise effect to where our mask is. Okay, let's increase the amplitude a bit more to 0.3 or 0.7, and let's add a convert VDB node to convert our distance VDB to polygons, and let's enable the smooth shading. Okay, and you can always go back at the attribute paint node and paint your mask. Okay, let's add a red color at the inside by using a mask by ambient occlusion node. Let's connect that, and here click on this visualizer to visualize our ambient occlusion, and let's check remap combined mask to use the ramp. Let's reverse this domain. Okay, and after that let's add a color node, and let's change the color type to ramp from attribute and use our mask, and go into the mask by ambient occlusion, click on this visualizer to disable the visualization of our ambient occlusion from this node. So now we are visualizing our color, and let's add a red color at the inside, and at the outside let's change this to a gray color, darkish gray, and let's adjust the ramp. Okay, let's input our sphere into this setup, and onto the sphere let's increase its Y size, and let's connect that, and here let's see what this sphere gives us. So here we don't have any mask, so let's disable that, and onto the volume let's disable the blend because we don't have any mask. Okay, let's lower the amplitude down. Okay, so as you can see, you can create a detailed organic shapes with the sign distance VDB. Okay, let's create clouds with the volumes. Okay, so here let's add a geometry node, dive inside, and let's add a sphere node, and here we have a node called cloud, so let's connect that. So if I middle click here, as you can see, we are generating a 1 VDB, and it is a fog VDB, and its name is density. Okay, and here you can define your voxel size. So here it's using the max axis to add voxel. We can change this to by size, so here we can set exactly the size of our voxel. So let's change this to 0.05 or maybe 0.01 to create a more detailed volume. And let's go into the density. Here you can adjust your density ramp. Okay, so let's reset this ramp by changing this to revert to defaults, and here we have some scattered shapes, so let's add a secondary shapes. Okay, here we can define the shape size, so let's increase the shape size. So that's too much. Let's change this to 1 or 0.2. Okay, and after that let's add a cloud noise to add the noise to our current volume. and here you can adjust the amplitude. Let's increase the amplitude. Okay, so here we have the basic shape of our cloud. So let's decrease the amplitude down to 0.2, and in here let's increase our sphere size in the X, change this to 1, and let's go back and let's increase the amplitude to add more breakups to our cloud. And here you can adjust your element size. This is the noise size, so here we can adjust the noise frequency. Okay, so let's add a font, and in here let's type cloud, and let's add a poly extrude node to add the thickness to our font. Let's increase the distance, and here as you can see the back side is hollow, so let's add an output back to add the gaps. Okay, and after that let's add a cloud node, and let's increase the uniform sampling to 100 or maybe 200, and after that let's add a cloud noise to add the noise. Let's increase the amplitude, and in here let's increase the spacing in our font by changing the tracking. Let's give some space, and now let's see with our cloud noise applied, and let's increase our density scale. So let's go into the cloud node and onto the density. Let's increase the density multiplier, so let's change this to 50. 50 is maybe a lot more dense. Let's change this to 25. Okay, and also let's increase the sampling to 300 to add more detail. And onto the cloud noise, let's increase our element size, or maybe lower our element size, and adjust the amplitude to 0.08. Okay, so here we are creating clouds from our font. Okay, and let's add a box. Here we have a box. Let's adjust our box Y size and increase our X size. So let's convert our box into cloud. Let's increase the uniform sampling to 300, and let's add a cloud noise. Let's increase its amplitude. Let's keep increasing our amplitude until we see some interesting breakups. Okay, so that's looking a lot more like a cloud. Okay, and you can convert this node on your own. So for example, let's add a VDB from polygons. Let's connect it here, and let's change this to a fog VDB by unchecking the distance VDB and enable the fog VDB. And let's lower the voxel size down to 0.01, and here as you can see we have a very thin fog. So let's add a volume visualization node and increase our density scale to 10. So this is an density multiplier. Okay, and after that let's add a volume noise fog, because this time we are using a fog volume. So let's connect it here, and the noise is set to add. Let's change this to multiply. We want to multiply our noise with the fog, and let's increase the amplitude and lower the voxel size. And the range, we are only using the positive values for our noise range, so let's change this to 0 centered, which means we have the values 0 and 1. Okay, so where the noise value is 0, we are basically removing our density. Okay, let's increase the amplitude, and let's also increase the element size. Let's change our box size in the X direction. Let's increase in the Z direction as well. Okay, so here we are adding a cloudscape. We are creating a cloudscape, so we have some clouds in the sky. Okay, and to increase the quality, let's lower the voxel size even lower to 0.007, and let's add the volume visualization after we've applied the noise. Let's increase the density scale to 20, and here we have the shadow scale. Okay, so that's the fog VDB. Okay, and also you can convert this fog VDB into polygons as well. So let's add and convert VDB node, and let's convert this to polygons. So now we are converting our fog VDB to polygons, so the normals are not correct, so let's add a reverse node to reverse our geometry normals. Okay, so here as you can see, now we are converting our fog VDB into geometry, and onto the convert VDB, let's increase the adaptivity to add more divisions where we have lot more detail. Okay, let's change this to smooth shaded. Now let's create our very first smoke simulation from scratch. So let's create a geometry node and dive inside, and in here let's add a sphere. So this is the sphere, so I want to emit smoke from my sphere. So my source for emission is the sphere, because we need the source for the smoke emission. Okay, and after that let's add a node called pyro source node. So the pyro source node will convert our geometry polygons into points by removing all of the polygons. Okay, and in here we have the mode. We can set this to keep input, which means the input number of points. Okay, and you can change this to surface scatter. So now we are scattering the points onto the geometry surface, and you can change the number of points by decreasing the particle separation. So let's lower the particle separation to 0.01. So now here as you can see, we are generating lot more points, and you can also change this to volume scatter. So now we are adding the points at the inside of our geometry as well. And onto the initialize, let's use the source smoke to initialize our source. So what it will do, it will add two attributes, the density and the temperature. So if I middle click, we have three attributes. We have the P scale, because we have here the particle scale. Okay, so this node is creating three attributes: the density, P scale, and the temperature. Okay, and let's convert these points into volumes. So we can use a node called volume rasterize attributes. So let's connect that, here onto the attributes, let's select our density attribute. Okay, so here we have the fog volume. So if I middle click, it's a VDB fog volume named density. Okay, you can adjust the voxel size here. So let's link this voxel size copy parameter to the particle separation. We want this to be same. So let's say paste relative reference. Okay, so if we adjust the voxel size, we are adjusting the voxel size as well as the number of points. Okay, so here we have the source ready. So let's create a DOP network, and let's connect this into our first input and set the display flag to the DOP.NET, and let's dive inside. So now we are in the dynamics. Okay, so we are in the DOPS dynamic operators. So if we right click, now the tab menu is changes. So now we have all the nodes related to the DOPS context. Okay, and in here let's add a smoke solver. So if we type, we have the smoke solver sparse. Okay, and we have the smoke solver normal one. So smoke solver sparse is fast and efficient because of being sparse. So let's use the smoke solver sparse and add it. Let's connect this into the out, and the smoke solver requires a smoke object to store the data and the fields. So let's add a smoke object, and let's connect this into the first input. And now the smoke solver throwing an error because now it's need a source. So let's add a volume source node, and if you hover over to the smoke solver inputs, so here as you can see, the first one is the forces and this one is the sourcing. So let's connect the source into the sourcing input of our smoke solver, and let's bring up the parameter for the volume source node, and here the input set to SOP, which means you can select the SOP node from here, or we can change this to first context geometry, which means this input. Okay, and in here where it says initialize source smoke, so let's click that. First we need to click another option. Let's change this to source sync, and now let's change this to source smoke to initialize. Okay, so now it is importing the source volume. So we have the source volume density, and we are importing it into the target field density. And please note that the volume inside of DOPS are called the fields. Okay, and let's click in large field to contain the source. Okay, and let's bring our play bar and hit play. Okay, so here as you can see, we have imported our source into DOPS. So now our smoke is not moving. Our smoke is imported, but it's not moving because currently we don't have any forces, and the smoke solver is still throwing an error, and it is throwing an error because we are using the wrong smoke object. So let's add a smoke object sparse one. Okay, I accidentally select the smoke object for the normal smoke solver. So let's use the smoke object sparse, and let's connect it here. Now the error is gone. Let's remove our smoke object, and let's go back onto the first frame and hit play. Okay, to get our smoke moving, we need the forces. So here onto the volume source node, let's add the temperature. So here we are using the source volume temperature, and we are targeting into the DOP field temperature. So if we go back and middle click, here as you can see, we only have the density and we are not creating any volume named temperature. So let's go into the volume and let's add our temperature. And now if you middle click, now we have the density and a temperature. Now we have two volumes. So now if we dive inside and hit play, and let's click on this clock button to enable the real-time playback and hit play. So now here, as you can see, our smoke is moving due to temperature. Okay, so here onto the smoke object, we can adjust the voxel size. So that's the resolution of our smoke simulation. So let's lower it down to 0.03 and hit play. And now, as you can see, we are adding a lot more detail to our smoke. Okay, and here onto the smoke solver, we have the option for our simulation. Okay, and if I enable the gravity tab, here as you can see, we have the gravity built in, and the gravity direction is set to the negative y direction. So that is because the gaseous simulations tend to move at the opposite side of the gravity. Okay, so if I change this to positive y, now our smoke will be going down. So if I bring the playback to the first frame and hit play, now as you can see, our smoke is rising at the opposite side of our gravity. Okay, and we can also change this to x. So let's add a -1. If you want to move your smoke on this side, let's zero out our y and hit play. Okay, -1 of the x-axis are on this side, so now we are moving our smoke onto the positive side of our x-axis. Okay, so let's zero it out and set the gravity direction to -1. Now we have our smoke moving upward, and if we go onto our volume source node, and here we have the temperature, so let's increase the source scale to 2. So now we are adding more temperature, which means we have a more hot smoke. So if we hit play, now as you can see, our smoke is rising fast. So let's increase it even further to 10 and hit play. And here as you can see, we have a very fast moving smoke. Let's change it back to 1. Let's go back onto the smoke solver, and here we have the wind force to add a wind. So let's add wind in the x direction. Let's change this to 1 and hit play. Now as you can see, our smoke is leaning toward the x-axis. Let's increase our wind force to 5 and hit play. Now as you can see, the wind is moving our smoke in the x direction. Okay, and here we have the time scale. So if I zero out my wind, and the time scale is the overall time multiplier. So if you want your simulation to be slower, you can lower it down. So if I change this to 0.2, now our smoke will rise slowly. Here as you can see, we have a very slow simulation. And same way, if I increase my time scale to 2, now we will have a faster simulation. Okay, let's change it back to 1. And here onto the advanced tab, we have the option to use the OpenCL. So use OpenCL means that our simulation will use our GPU to calculate the simulation. So we are using the graphics card for the simulation. So now if I hit play, Here as you can see, now we have a faster simulation. Okay, and here as you can see, our smoke solver is throwing a warning. So if I click on this warning icon, so here it's saying that the OpenCL is not support the sparse mode. It means that when you use the OpenCL, it is using the graphics card to simulate, but the simulation is not sparse. Okay, which means that at the entire bounding box, this bounding box, we have voxels filled. Okay, so we are not using the sparse simulation. So that's what the warning sign mean. Okay, so let's disable that. Now the warning sign is gone. So now we are using the sparse simulation. So if I change this to wireframe, here as you can see, these are our active voxels. Okay, and they are sparse. Let's change it back to smooth shaded to see our smoke. So let's add a turbulence into our simulation. So hit tab and add a gas turbulence node, and turbulence is a force, so this one goes into this input where it says forces. So let's connect it here at the forces, and here we have the turbulence, and we can adjust the noise scale. So let's increase this to 1, so that's basically the amplitude of noise. And here we have the swirl size for the frequency of our noise, and let's hit play. Here as you can see, we are adding more detail to our smoke. So let's increase our scale to 5 and hit play. So now we have a lot more turbulent smoke. Okay, let's increase the swirl size to 2, and let's increase our scale to 10. So now we have a very low frequency noise. Okay, so basically what the turbulence noise is doing, it's disturbing the velocity fields. So if I go into the visualization and visualize the turbulence and hit play, let me stop my simulation and go into the smoke object, and here we have the visualizer. So let's uncheck the intensity field to not visualize our intensity. So here as you can see, these are the velocity fields, and the turbulence, gas turbulence is adjusting these velocity fields. Okay, so let's uncheck it and go into the smoke object, and here let's enable the velocity visualization. Okay, so here we can see the full velocities. Okay, and not just for the turbulence. And if I disable the gas turbulence node and hit play, let's zoom out into there, and here as you can see, we have a very smooth and fine velocity fields. Okay, and if I enable the gas turbulence, and let's lower the scale down, and let's lower the swirl size down, and if we hit play, so here as you can see, the gas turbulence is adding noise to our velocity fields. Okay, so let's go back onto the smoke object, and let's uncheck the velocity visualization and enable the intensity visualization to visualize our smoke. And if we go back, and we have the smoke solver at the SOP level, so if you type the pyro, so here we have the pyro solver node. So this is the node at the SOP level, so it's basically a digital asset, so which means you can dive inside. So here, as you can see, we are inside of the topnet, and if I click on this topnet, okay, so here we are using the Pyro solver and we are importing the source from here. Okay, so this node is basically a digital asset. So let's connect this into our sources, set the display flag to the Pyro source. So here we have the option for the smoke solver, and we have the bound for the maximum bounds for our simulation. So if I limit my maximum size to, let's say, 2 in Y, so now if I hit play, here as you can see, we are limiting our smoke simulation bounds. Okay, let's uncheck that, and here onto the boundary condition. So we have the treat X as an open or close. So it means that, let me enable my limit max size. So if I hit play, here as you can see, after we have reached our limit, our smoke is cutting off. So what I can say that treat Y is as a closed above, which means the positive value. So closed above means that now after the 0, so let's adjust this to 2 because we have set our size to 2. So let's change this to 2. Okay, so after the Y value of greater than 2, our boundaries will act as a collider. So now if I hit play, here as you can see, so let me uncheck my limit max size and hit play. So here as you can see, now we are not cutting off our simulation, but after the Y size of 2, when our smoke has reached at the 2 unit, our container is act as a collider. Okay, and here we have the collisions and the sourcing. So that's the volume source node. We are importing the density and the temperature and as well as other fields. And here we have the fields tab for the dissipation, and the shape tab to add the forces. We have the wind force and the disturbance, turbulence. Okay, and at the look tab we have the shader assigned to our smoke simulation. Here I can adjust the density scale to create a thicker smoke. Okay, and at the advanced we have these solving options, and after that we have the output. So we are outputting these fields. So if I middle click, here as you can see, we are outputting the 6 volumes: density, temperature, flame and velocities. So if you don't want these fields, you can just uncheck them. Okay, and now if I middle click, now you see we only have one field, density. Okay, so that's the basics of setting up the smoke simulation. Okay, and in the next lesson, let's explore some option of the Pyro solver node. Okay, now let's take a look at some of the settings of our Pyro solver node. Okay, so first one, we have the setup. Here we can adjust the voxel size, and here we have the time scale to adjust the overall speed of our simulation, and here we have the simulation type is set to sparse, so we can change this to dense to create a non-sparse simulation. And we also have the minimal OpenCL solve. So the minimal OpenCL solve is use our graphics card to simulate our sparse simulation. Okay, so and here we have the bounds to set the maximum bound for our simulation, and let's change this to open, so I don't want the closed boundaries. Okay, and here we have the tab for collision. So if you want to add collider into your simulation, so let's create a box, and let me template my box, and let's increase its X size, and let's move the box up, and also let's increase its the size. Okay, and here we have the second input for the collision geometry. So let's connect our box as a collider. So now if I hit play, here as you can see, our smoke simulation is colliding with our box. Okay, and here we have the option for setting the collision, so we can activate the collision. So here activation set to 1, which means we are using the collision. So if I set this to 0, now our collider will be ignored. Okay, so let's set this to 1, and here we have the option to use the deforming geometry, so which means that if our box is animated, so if I animate my box, so here onto the transform node, let's animate our X position. So first let's set it here and add a keyframe by press and hold the Alt key and click on this parameter to add a key. And let's go back at the 40 frame and let's change the center to 0 and hold Alt on your keyboard and press the left mouse button to add another key. So now if I scrub my play bar, here as you can see we have an animated box. So if I set the display flag to the pyro solver, okay, here as you can see our box is interacting with our simulation. Okay, and if I uncheck the use deforming geometry, now our animation is ignored. Okay, so let's enable that and let me remove my box. And here we have the sourcing. So to import our source into DOB, so this source, so here we have the source volume density and we are adding it into the DOB field density. We can adjust the density scale if you want to create more thicker smoke. So let's add the density scale to 10 to create a more thick smoke and hit play. So here as you can see we are emitting a lot more smoke. Okay, let's change it back to 1, and here we have the option for fields. So the first one is for the density. So here we have the density dissipation. So this will control how long our smoke will live. Okay, so if I increase the dissipation, now we have a shorter smoke because we are dissipating a lot of smoke. Okay, so if I change this to 0.2, okay, let's increase this to 0.3. So here as you can see we are dissipating our smoke over time. Okay, so let's change it back to default 0.1, and here we have the option for temperature, and here we have the cooling rate. So if I increase my cooling rate, now our temperature will cool down quickly. So if I hit play, now as you can see as our smoke is rising, its speed is becoming slow because we have a lot of cooling happening. Okay, so if I decrease the cooling rate, here as you can see our smoke is rising because our temperature is not cooling as quickly. Okay, so if I increase this to 1, here as you can see we have a very slow smoke simulation because our temperature is cooling down quickly. Okay, and into the shape tab we have the option to refine the shape of our simulation. So first one is the buoyancy. So the buoyancy is the force that affect that when we have a hot temperature where we want our smoke to rise. So here we have the direction, which is the gravity direction. Okay, so that's basically a buoyancy force that is causing our smoke to rise up due to temperature. Okay, we can adjust the buoyancy scale, so that's the overall scale multiplier. So if I increase the buoyancy scale, now we will have a faster simulation. And if I lower the buoyancy down, now we will have a slower simulation. Okay, so let's change it back to default to 1. And after that we have the wind. To apply the wind, here we can specify the wind direction as well as the wind speed. Okay, and we have the disturbance. So the disturbance is a small scale noise into our smoke. Okay, so if I go into the setup and let's lower the voxel size to add more detail to our smoke simulation. So 0.01 is a lot slower, so let's change this to 0.03 instead. Okay, so if I go into the shape tab and let's increase the disturbance to 50. Okay, here as you can see we are adding a high frequency noise into our simulation, and you can adjust the noise by the block size. Okay, so let's disable that. And down here we have the turbulence, so let's enable that. So here we can adjust the turbulence scale, so let's increase this to 5. And here we have the source size, which is the frequency of our noise, and let's hit play. Okay, so here as you can see we are adding the turbulence, so that's a large scale turbulence. Okay, so let's disable that. And after that we have the shredding. So the shredding will add a velocity field where we have a high temperature, and it is using the flame field. So right now we don't have any flame field, so the shredding won't affect our simulation. So even if I change shredding, it will not have any effect. Okay, so if I change my threshold field to temperature, okay, because we do have temperature in our sim. Okay, so here as you can see we are adding some detail where we have high temperature. Okay, and here you can adjust its block size. So let's disable the shredding, and after that we have the flame expansion, so that is for fire and the explosions. Okay, and lastly we have the viscosity, so you can add the viscosity to create a more viscous simulation. Okay, so basically we are smoothing out all of our details to create a more wispier smoke. Okay, so let's disable that. And here we have the guides to visualize. So if I enable my turbulence and enable my turbulence guide and hit play, here as you can see it is displaying me the guide for the turbulence. Okay, so I can adjust the swirl size. Let's lower this to 0.1, and here as you can see it is visualizing the scale of our noise. Okay, so we are creating a low frequency and a high frequency noise. Let's change the visualizer shape guide to disturbance. Okay, and we also need to enable the disturbance. So here as you can see we are visualizing the disturbance. It is showing where the disturbance is being applied. Okay, so if I hit play, here as you can see we have the guide for the disturbance. And if we take a look at our smoke, and here as you can see we have this low frequency noise, high frequency noise into our smoke simulation. Okay, So let's lower the disturbance down to maybe 10 and hit play. And the value of 10 is looking good. Okay, so let's disable the guides by changing this to no guide. And after that we have the look tab. So at the look tab we have the shader assigned to our solver, and here we can adjust the smoke density, and here we have the fire. So currently we are not emitting fire, so these parameters won't have any effect. Okay, so here I can adjust the density of our smoke and the smoke color. So if I change this to blue, here as you can see we have a blue smoke. And here I can adjust the shadow density to create a more darker shadows. Okay, and the color is set to constant. You can change this to ramp. Okay, so now we are using the ramp to set up the color for our smoke. So if you click on this gear icon, we have some presets. So we have a preset for black body. Okay, and we can also change this to infrared. Let's change it back to the constant, and let's set our smoke color to white. Okay, and at the advanced we have the advanced level solver option. Okay, and at the output, here we have the fields to output and to save caches. So here you can set your field that you want to write out. So if you want to write out the temperature, let's enable the temperature, and if I middle click, here as you can see now we are adding the temperature. Okay, and here as you can see we have the volumes, so which means these are the Houdini volumes. So we have the option to convert them to VDB. So now if I click, here as you can see now we are converting these Houdini volumes to VDB volumes. Okay, and here we have the option to use the 16-bit float. So the 16-bit float is a precision. So by using the 16-bit float we can make our cache size lower. Okay, and after that you can add a file cache node and connect this, and at the file cache node you can specify your cache name. Okay, and the base folder where you want to write your caches, and here we have the frame range, and press the save to disk option to write out your caches. Okay, and when you have written out your caches, you can click load from disk option to load your caches. Okay, so currently because we haven't written out any caches, so that is why we can't see anything. So let's uncheck that. Okay, and here onto the pyro solver. So if you want to edit your smoke simulation, and for example if you want to add more noise, so for example if I add here onto the shape tab, I have enabled the turbulence. So that turbulence is a small scale value. We have the source size set to 0.9. So let's say I want to add another turbulence, so let's change its source size to 2. So we are creating a high frequency noise. So if we dive inside, so here we are at the DOP level and we have these inputs. So here we have the sourcing if you want to add more source. Okay, and here we have the forces. So I can add a turbulence, gas turbulence, and let's connect that. And here I can add another turbulence on top of the turbulence that we have set here. Okay, so here we are creating a low frequency noise. So let's set this turbulence to a lower frequency. The source size is set to 0.6, and let's increase its scale to 10. Okay, and let's hit play. And here, as you can see, we are layering our turbulence, and you can add more. For example, I want to add the disturbance, so here we have the gas disturb node, and if you want to add this, we can add an emerge node and merge both of these micro solvers. So these are what called the macro solvers. Okay, so here we are adding the gas disturb macro solver, and the mode is set to continuous. You can change this to block based to match your disturbance here. So this is set to block based. Okay, and you can add more turbulence. So let's add an gas turbulence to keep adding more layers of noise to add more breakups to your simulation. Okay, so this one, let's set this to default, and onto the gas turbulence, this one, let's change it to 5. Okay, and let's hit play. So here, as you can see, we have a lot more layering going on into this simulation. Okay, now let's talk about divergence. Divergence field is used to control the expansion of your simulation, smoke simulation. Okay, so here, if I go into the fields and onto the guide, if I enable my pressure field and hit play, so here, as you can see, we have the pressure visualize. So where we have the high pressure, we are using the divergence to expand our smoke simulation. Okay, so let's set up our divergence field. So if we go into the sourcing, and let's add another source by clicking on this plus button and down here, and let's use our current density field, and let's use this as a divergence. Okay, so now we are using the density to target the divergence, and if I hit play, so here, as you can see, our smoke has a lot more volume. So if I enable the divergence scale to a higher value, let's change this to 10 and hit play. Here, as you can see, our simulation is basically exploding. Okay, so let's set up our divergence field here separately. So let's duplicate our whole setup, and onto the pyro source, let's clear out all these fields, and let's add a divergence attribute. So we are adding a divergence attribute. So let's go into the volume rasterize attribute node, and here let's clear out all of these attributes and select the divergence. Okay, and let's merge this with our source, create a merge. Let's merge both of these source and connect it into the pyro solver, and let's add a transform node in between. Okay, let's make its scale bigger to 2, and also let's move him up a bit. Okay, and let's go into the pyro solver and into the sourcing tab, and down here let's use our divergence field. Okay, so that we have created here, and use this as a divergence. And if I hit play, so here, as you can see, whenever our smoke is contacting with our divergence field, it's starting to expand. Okay, so let's go into the pyro solver and onto the shape tab. Let's disable the turbulence for now, and also let's dive inside and remove all of these noises, turbulence that we added. Okay, and let's hit play. Let's move our divergence a bit up. Okay, and hit play. And here, as you can see, we are expanding our smoke simulation. Okay, so the divergence can also have a negative value. So if you go into the sourcing and into the divergence, and if I add a negative divergence, let's change this to -10. Okay, so now we will have a suction effect. Okay, so here, as you can see, whenever it contacts with our divergence, our smoke is sucking inside, gets sucked inside. Okay, so divergence can work in both ways. Let's add the divergence to 2 and hit play. And after reaching the point, here, as you can see, we have a mushroom shape. Okay, and now if we take a look at our pressure field, go into the field and enable our pressure field, and let's increase the divergence scale to 10. Okay, and here, as you can see, where we have contact with our divergence field, we have a lot higher pressure value. Okay, and we can also visualize our divergence field. So let's select the divergence, and here, as you can see, we have the divergence visualized here as a red smoke. Okay, so if I move my divergence field down, here, as you can see, we are moving our divergence visualizer. Let's change this to 1. Okay, so here we have the guide for the divergence. Let's hit play. Okay, so the divergence field is essential in controlling the expansion of your simulation. Okay, now let's set up our large scale smoke simulation. So let's create a geometry node and dive inside, and in here let's add a sphere, and let's increase the sphere X size and also the Z size. Okay, something like that. And after that, let's add a pyro source node, and let's initialize it to source smoke. It will create 2 attributes, density and temperature. And after that, let's add a volume rasterize attributes node to convert our points to volume, and let's select our density and temperature. Okay, and let's add our pyro solver node, and in here let's copy this voxel size, copy parameter, and paste it into our volume rasterize attributes voxel size, paste relative reference, and also the particle separation. Okay, paste relative reference. So now we can adjust our overall simulation resolution by changing this parameter. Okay, so let's hit play. Okay, so we have a very less density smoke. So let's decrease the voxel size to add more resolution. So let's change this to 0.05 and hit play. Okay, so we have a lot less density, and that is because at the pyro source node we are using the points of our sphere, so we have lot less points. Okay, so let's change this to volume scatter. Okay, so now we are generating a lot more points, and now we have a lot more density at the source. And now let's hit play, and here as you can see, as a result we are emitting a lot more smoke. Okay, so the source is very important. Let's zoom out a bit and let's break up our simulation. So here onto the pyro source node, first let's break up our source. Okay, so after we have created the points, let's add an attribute noise node, and let's noise out our density attribute. So here we have the attribute data type, and right now it is set to vector. So if I middle click, we have a float attribute density, so let's change this to float, and in here let's select our density and let's remove the CD, we don't need that, and let's set the display flag to the volume rasterize node, and in here the operation is set to add. Let's change this to multiply, and the range are set to positive. Let's change this to 0 centered. Okay, and let's also animate our noise by going to the animation and check the animate noise. Okay, so now we have a lot more breakups going on at our source. Okay, let's increase the amplitude, and also let's decrease the element size. And now let's hit play with our pyro solver. Okay, so here as you can see, we have already a lot more breakups going on just by changing the source. Okay, and let's also add velocity to our source as well. So right now we don't have velocity, so let's create one by adding a node point velocity, and let's connect it here. And initialization, let's set this to value and give him a positive y-axis of velocity, and click on this eye icon and click on this V attribute to visualize our velocity. So here these yellow lines mean our velocity direction. Let's go into the curl noise and add a curl noise to our velocities. Okay, the animated is checked on, so which means our noise is animated. Increase the swirl size. Okay, so now we have V for velocity, so let's add that into the rasterize attribute. Let's use our V. Okay, so now we do have a V volume. Okay, and here onto the pyro solver and onto the sourcing, so we have density to density, and we have temperature. Burn, we are not using that, so let's remove it, and we have V to well. Okay, and let's hit play with our new velocities. Okay, so we have a lot of dissipation going on, so go into the fields and onto the dissipation. Let's lower the dissipation to 0.01 and hit play. Now as you can see, we are not dissipating our smoke as much. Okay, and let's go back at the sourcing and let's increase the velocity scale to 10, and let's see. And here, as you can see, our source velocities are breaking our smoke simulation. It's adding more breakups. Okay, so let's increase the density scale to emit more smoke. So let's add the source scales to 10, set this to 10. Okay, so now we are emitting a lot more density. Okay, and let's go on to the shape tab and let's enable the disturbance to add a small scale noise to our velocities. Okay, and let's change the disturbance to 30. And here, as you can see, we are breaking up our mushroom shape into smaller little mushrooms. Okay, and let's enable the turbulence and let's set the turbulence to 5 and hit play. And we can always enable our guides. So here we have the guide, so let's add the turbulence guide. Okay, so here we have the guides for the turbulence. So let's adjust the swirl size. Okay, so here, as you can see, we now have bigger swirls. Okay, so let's see with the swirl size set to 3, and let's change this to no guide and hit play. Okay, first let's go on to the setup and let me increase the voxel size for faster preview. So let's change this to 0.1. Okay, so now we have a very fast simulation. And let's go back onto the shape tab and let's add a wind at the X direction and let's hit play. Let's increase the wind speed to 5. And here, as you can see, the wind is moving our smoke at the X direction, pushing our smoke simulation at the X direction. Okay, and let's go back at the setup and decrease the voxel size to check with the high resolution. Okay, and here, as you can see, at the top we have some problems going on. So if I go back, here, as you can see, our smoke is cutting off, and that is due to the bounds. Our smoke is moving fast. So let's go into the bounds, and here at the resizing, let's add a padding. So right now the padding is set to 0.3. Let's change this to 0.7 to add a headroom. Okay, so now, as you can see, at the bounding box we are adding the padding, and now our simulation is not cutting off. Okay, okay, so let's go back at the shape tab and onto the turbulence. So right now we have a larger swirl size turbulence. So let's add another turbulence for small scale noise. Okay, so let's dive inside the pyro solver node, and at the forces let's add gas turbulence node and connect that. And for this one, let's set its scale to 5, and the swirl size default is good. Okay, so we are creating a smaller salt size, and let's hit play. And here, as you can see, we are introducing a lot more smaller detail into our smoke. Okay, and let's dive inside the pyro solver node, and in here let's add another gas disturb node, and let's merge both of them. And to this gas disturb node, let's change this to block based and change the block size to 0.1. Okay, so here we are creating a more smaller size gas disturb velocities. Okay, and let's add a gas vortex confinement. So what the gas vortex confinement node will do, so let me go back onto the pyro solver node, into the fields and onto the field guides. Let me enable my velocity field and hit play, and let's collapse the field guides folder and add more divisions for better visualization. Okay, and the visualization is set to 3D. Let's change this to plane to add a slice to slice our velocity volumes. Okay, so now we have a single slice. So here, as you can see, as our simulation proceed, our velocities are smoothing. Okay, so what the gas vortex confinement will do, it will boost the small noise where we have the turbulence. Okay, so when we add the turbulence and the disturbance, we have this small scale velocity noise. Okay, and the simulation will try to smooth out that noise. So the vortex confinement will help to retain those small scale velocity noise. Okay, so let's change this to 5, the confinement scale. Okay, and now let's go back and onto the field. Let's set this to no guide, and let's hit play, and let me generate the flipbook of our simulation. So if you come over here we have the option to render the flipbook. So right click, flipbook with new setting, and here you can adjust the frame range. So let's give him an range. I want to make the flipbook for the 72 frames. And onto the size, here you can adjust your resolution. So let me uncheck that. So if you uncheck the resolution, now it will use the current scene dimension for the flipbook generation. Okay, and press start to create flipbook. Okay, so here I have generated the flipbook for the 43 frames. So let's hit play, and here we have the flipbook, and here as you can see our smoke is moving very fast. Okay, so let's go back and onto the shape tab. Let's lower our buoyancy scale down. So the buoyancy is the force that is causing our smoke to rise up due to the high temperature. Okay, so let's lower this down to 0.5, and let's generate flipbook again. Okay, so here is the flipbook, and here as you can see, now because we have slowed down our smoke rising simulation, now we have a lot more disturbance going on in the smoke. So now we are breaking our smoke too much. Okay, so let's go back, and here onto the turbulence, let's scale down the turbulence to 2, and also onto the disturbance. Let's use the control field for that. So we are gonna use the control field name speed. So let's go into the fields and let's enable the speed field. So now our solver will calculate a field name speed, which will store the speed of our simulation. Okay, so here onto the shape, and we can define the range of our speed by using the speed field. Now we are adding the disturbance where our smoke is moving, okay, and not disturbing the smoke that it has come to rest. Okay, so let's change the speed because our right now smoke is moving fast. So let's change the speed to 1 to 5. Okay, so it means that disturb only where at least the smoke is moving. Okay, and here onto the fields and onto the temperature, let's increase the cooling rate to higher value. Okay, and also let's dive inside, and here onto the gas turbulence, let's lower the scale down to 1, and here we have another gas disturbance, and our block base is set to 0.1. and onto the control field, let's use our speed field here as well. Okay, and let's set its range to 1 to 5. And because we are using a smaller block size, we need more voxel to capture the small details. Okay, so right now the voxel size is set to 0.07, and now let's see. Okay, so now we are not breaking our smoke as much as we have the broken up smoke before. Okay, and that is looking good. Now let's write out our simulation cache. Okay, so let's go into the output tab of our Pyro solver, and let's uncheck all the fields that we are not going to use. Okay, so for example, let's disable the temperature and the flame and the velocity and the CD as well. So we only need the density for rendering smoke. Okay, and after that, let's convert this to VDB and use the 16-bit float. This will save our disk space by lowering the file cache size. Okay, and if I middle click, now here as you can see, we only have one volume, VDB volume density. Okay, and after that, let's add a file cache node and connect its output to the file cache, set the display flag to the file cache, and in here we have at the base name has an expression $hip name $OS. So the $hip name means the current hip file that you have saved. Okay, so if I remove this expression and change this to only $OS, so the $OS means that the operator stream, so the operator name. So right now the operator name is set to file cache 1, and if you hover over to that parameter and press the middle mouse button to see what the expression is evaluating. Okay, so now it's evaluating file cache 1. So let's rename this to smoke, and here as you can see, the base name is changes. Okay, so that's the $OS expression, and here you can define the file cache format. So here we have the bgo.sc. You can change this to VDB. So let's use the bgo.sc. The bgo.sc is the Houdini native file format. Okay, so let's use that. And here we have the base folder. So the base folder we have the expression $hip/geo. So let's change that. Click on this file chooser. Okay. So in here, let's go into our $hip variable and select the sim folder and hit accept. Okay. So now we are using the $hip sim folder to write out our caches. And here we have the version system. So what it means that, let's say if I save my current file cache, so here we have the value, it is set to frame range. So let's change this to single frame. So now we are writing only single frame at the disk and press save to disk. Okay. So the caches has been written out and the load from disk option is checked on. And if I open my folder, if you click on this folder button, it will open the directory of where you have stored the caches. So inside we have the smoke base name, and here we have the v1 variant 1 and the .pgo sequence. Okay. And if I change this to variant 2 and let's say I change some settings, so that is my variant 2. And now if I press save to disk, now if I open my folder again and the smoke, here as you can see, we have the variant 1 and we also have the variant 2. Okay, so we are not overwriting our existing cache. Okay, so that is good. Let's change it back to variant 1 and let's use our frame range. And in here, let's cache out 120 frames by changing the global frame range to 120. Okay, so here the frame range automatically set to 120. Okay, and now press save to disk option to write your caches. Okay, all done. So I have written out all the caches. Okay, and here as you can see we have our smoke simulation. And now let's render this. And for rendering we will be using the Ace's color space. Okay, so if we go into the help and contents and search for setting up Aces in the shading and rendering user guide. Okay, so let's click that. So here we have the instruction for setting up Aces using OpenColor.io, and here as you can see we have the explosion without the Aces color space, and this is with the Aces colors enabled. Okay, so here we have the web page to download the Aces color profile. And what the Aces is a color encoding system, and the Aces have a much wider color gamut. Okay, so here we have the website opencolor.io.org. Okay, go to that website and click on this download button and download this sample OCIO configuration. Click this button to download. Okay, and here I have downloaded the OpenColor.io configuration, and inside we have the folders and the Aces version. So the Aces 1.0.3 is the version that we are going to use. Okay, so here I'm copying this Aces folder and pasting it into my C drive. Okay, so here onto the C I have created a folder named Aces. Okay, and here I have pasted the Aces 1.0.3, and here we have the configuration. Okay, to set up our Aces configuration, just go into the system settings and in here search for the environment variable, edit the system environment variable, and click on this environment variable button, and in here create a new environment variable, and the variable name is the OCIO, so it should be in capital OCIO. Okay, and for the variable value, browse the file. So here I have stored my file inside of the C ACES 1.0.3 and the config.ocio. Open that and press the OK button to create your OCIO environment variable. Okay, so here I have already created my environment variable. Okay, press OK, and after that restart Houdini to have the ACES color profile installed inside of Houdini. Okay, so we can check if the ACES has been installed. So if we go into the perspective and enable the correction toolbar, and right here as you can see we are using the ACES color profile. Okay, and here we have the output transform, so we are using the ACES color and transforming it into the sRGB color space. So in the next lesson, let's import this our smoke into Solaris and render out our smoke. Okay, so after the ACES has been installed, now let's import our smoke into Solaris and let's render this. And after the smoke, let's create a null at the end, and let's call this one out smoke. Okay, and let's go back, and from the object let's go to the stage context. So now we are in the Solaris. Okay, and here we are working with the UST file format, UST, the universal scene description file format. Okay, so let's import our smoke from object level into Solaris. Okay, so let's go into the stage, and to import inside of Solaris we use a node called SOP import node, and into the SOP import here we have the SOP path. So let's select our Geo1 and the out smoke null. Okay, and here as you can see we are importing our smoke inside of Solaris. So let's select our camera tool to navigate in the scene around. Okay, and in here let's select an angle for rendering, and let me enable my shelf, and press and hold the control key on your keyboard and press the camera button to create the camera at the current view. Okay, so now we can select the camera tool and the lock button is on, so which means we can position our camera. Okay, so let's unlock our camera and let me hide my shelf, and here as you can see we have created a camera node. Okay, and let's add a light. Let's add a dome light and open the parameter for the dome light, and at the texture slot let's go into the Houdini pick HDRI and load the HDRI Heaven Skylight Garage HDRI. Okay, select that and hit accept. Okay, so we have imported the HDRI into the dome light. Okay, so let's merge this. So you can connect the node inside of Solaris like this. Okay, or you can add a merge node and merge these node like this. Okay, it's the same thing. So let me connect the wire from here and the here. Okay, so here we have the light and the camera, and let's set the display flag to the merge. Okay, so now here as you can see we are importing our HDRI. So if you don't want to see the HDRI as a background, click on this I button to bring up the display option, and go into the background and uncheck the display environment light as background. Okay, and onto the color scheme, let's change this to dark or maybe gray. Okay, and after that let's create materials for our smoke. So for that we are using a node called material library. So let's connect after the merge and dive inside the material library, and in here we are going to use the XPU Pyro preview shader. So this is the shader that the Karma XPU will use to render the smoke. Okay, so let's go back and bring the parameter for the material library and click on this auto fill material to fill the material slot, and click the assign to geometry, and in here we can select the geometry path. So let's click on this arrow button and come over here at the viewport, and let's select our smoke. Okay, so our smoke is highlighted. Press enter. Okay, and let's scrub our timeline, and here as you can see we have applied the shader. And after that let's add a Karma node, and the Karma node has two nodes attached to it. Here we have the Karma render setting and the USD render op. Okay, so let's connect the material library to the Karma render setting, set the display flag to the Karma render setting, and onto the Karma render setting we can change the render engine. So right now we are using the CPU engine, so let's use the XPU engine. So the XPU will use both our CPU and GPU to speed up the rendering process. Okay, and here we can set the resolution for our rendering. So you can select the presets from here, or you can type your own resolution. Okay, and let's select the camera tool, and here onto the perspective let's use the Karma option to start rendering using the Karma. Okay, so the rendering has done. Here as you can see the Karma render engine is fast. Okay, so let's adjust our lighting. So let's go into the dome light, let's increase the exposure a bit, and let's go into the transform and add the rotation at the y-axis. So let's rotate this at 60 degrees. Go into the base properties, let's load down the exposure to 1.5. Okay, and let's dive inside the material library and adjust our shader. So here we have the density scale. So we can create a thicker smoke by increasing the density scale. So if I change the density scale to 2, so we have a more thicker smoke, and if I change this to 0.1, so now we have a very thin density smoke. Okay, so let's adjust the density scale to our liking. So let's change this to 0.8 and check, and also let's change our smoke color to a darkish gray, and here we have the shadow density. Let's lower the shadow density, and let's adjust our smoke color to a more darker smoke, and let's decrease the shadow density even more to 0.1, and let's change our different render frame. Let's change the shadow density to 0.2. Let's increase the overall density of our smoke. Let's change it back to 1. Let's view it with our different frame, the frame number 50 maybe, and let's go back and adjust our lighting into the dome light. Let's increase the exposure, and also onto the transform let's rotate it at 80 degrees. So you can keep adjusting these parameters to look at your smoke. Okay, so let's select our camera from where it says no cam. So click on that and click our camera 1 to view with our camera. Okay, so let me adjust my camera again. So click on this lock button to lock the camera, and now we can place our camera to our liking position. Okay, so after when you have done your settings and you are happy with your results, go into the UST render op, and here you can set the valid frame range. So right now it's set to the render current frame, so let's change this to render specify frame range, and currently we are rendering our full frame range 1 to 120. Okay, and at the karma render setting, here we can specify where we want to write our image sequences. So at the output picture, and here we have the camera. Okay, so right now we are rendering inside of our $heap. So let's select that to change the location. So let's go into the $heap and into the render, and let's name our render smoke v1, and after that underscore and the $f. So the $f variable mean the current frame number, so we need to add the $f so that we won't overwrite our previous frame by using the same name. Okay, and after that dot exr to write our exr sequences, and hit accept, and let me change my resolution to HD 1920 by 1080. Okay, and let's go into the UST render op and press render to disk option to render out our sequence. Okay, all done. The rendering has been finished. So here at my project directory, so here we have the EXR sequences. Okay, so let's view them in the mplay. So let's go into the render and into the mplay and load the disk files, and here we have the window to load our EXR sequences. So let's go into the render, and here we have the smoke EXR sequences 120 frames. So let's load them and let's play. Okay, so that is our final smoke simulation rendered. Okay, now let's talk about fire. So let's create a geometry node, dive inside, and in here let's add a sphere for sourcing, and lay down a pyro source node, and set the mode to volume scatter, and this time let's initialize this to source burn. Okay, so for creating fire we are creating these two attributes. Now we have the burn and the temperature. Okay, and after that let's lay down volume rasterize attributes node, and in here let's select our burn and the temperature attribute and lay down a pyro solver node. And here, as you can see, let's bring up the play bar, check the real-time toggle for the real-time playback, and hit play. And here, as you can see, now we are emitting fire. So here, if we go into the sourcing tab, here we are importing the density to density. Okay, so currently we don't have any density volume. Okay, so let's uncheck that. Okay, and we are adding the temperature to temperature and the burn volume into the flame field. Okay, so now we are generating a field named flame. Okay, so here onto the fields, so here onto the intensity, we can emit the intensity from flame. Okay, so if you check that option, now our solver will emit the smoke from this flame. Okay, so let's increase the emission scale. Let's change this to 5 and hit play. Let's set the operation to add for maximum smoke. Okay, so now we are adding the smoke. Okay, and let's go into the look tab and let's increase the intensity scale. Okay, so now here, as you can see, we are generating the smoke from the flames. Okay, so let's go back onto the fields, and here we have the intensity dissipation. Okay, and for the flame, so here we have the flame, so let's collapse that. Here we have the flame lifespan. Okay, so if I change this to 0.5, now I will have a shorter length of fire. Okay, and we have a large smoke, so let's increase the density dissipation 0.7 and let's hit play. And here, as you can see, now we are dissipating a lot of smoke, so let's change this to 0.5. Okay, so this parameter controls the smoke dissipation and this is the flame lifespan. Okay, if you want the longer flame, you can increase the flame lifespan. So if I set this to 2, now I will have longer flame. And here onto the shape tab, we have this turbulence disturbance to shape our flames. So let's enable the turbulence. Okay, and let's increase the turbulence scale to 5 for a higher turbulence and hit play. Okay, so let's increase the voxel size. So if I go into the setup, we have the voxel size. Let's lower this to 0.05 and also copy this parameter and paste it onto this voxel size and onto the pyro source, the particle separation. Okay, and for the better fire visualization, let's change our background. So let's click on this eye icon and onto the background, choose the color scheme to dark. Okay, and let's go into the look tab. Let's create a more darker smoke color, and here we have the intensity of fire, and here, as you can see, so we have this hot area more solid. So for creating these transparent flames in the fire, here we have the ramp for the color. So let's reverse this ramp. Okay, by clicking on this reverse domain button. Okay, so now here, as you can see, we are basically creating a transparent flames, and let's bring this black knob a bit further to create a more transparent flamey look. Okay, and here you can adjust the intensity. Right now we are emitting flames from a perfect sphere, so let's break up our source. So let's go back onto the sphere. Let's change this to polygons, increase the frequency, and after that let's add a mountain node. And onto the animation, let's animate our source as well, and let's increase the amplitude. Okay, and onto the pyro source, let's change the mode to the surface scatter. Okay, so because it's a fire, so the method for the surface scatter will emit fire from the surface of our source, okay, which will create a more transparent flames. Okay, so now let's see the results. And here, as you can see, we are creating a much nicer flame, so we have a lot more detail into our flames. Okay, so let's go into the pyro solver, onto the setup, and here we have the simulation type. So we have the option to change this to sparse or dense or the minimal OpenCL. So let's click that. So the minimal OpenCL will use our GPU to accelerate our simulation. Okay, so now if I hit play, and here as you can see, we have a much faster simulation, but now our source is gone and the simulation is clipping. So let's go into the bound. So when you change this to minimal OpenCL, it will create these bounds. So now we are bound onto these limits. Okay, so let's increase the Y size, and this is the container origin. Okay, so let's copy this parameter, and in here let's paste relative reference. So now basically we are using the same value, so let's after that multiply it by 0.5. okay, so now when we change the size, we are placing our container at the floor. Okay, and let's go back and decrease the X size to 4 by Z onto the 4 as well. Okay, and now let's hit play. And for the sourcing, if we go into the sourcing, here as you can see, the limit source range has been checked on. So if I enable that, here as you can see, we are limiting our source to between 1 and frame 12. Okay, and if you increase this range, so let's say if I set the range to 30 and hit play, now here as you can see, we are emitting fire for the 30 frame. Okay, and you can also enable the cycle for looping. So if I set this value to be the same, so if I set this cycle length to 30, now we will have a looping effect. Okay, so here as you can see, our source is looping. So let's change this to 12 and change its cycle length to 12 as well, and hit play. Okay, so after 12 frame we are looping our source, so which mean if I create another source, let's say, let's copy this whole setup here, and onto this setup let's increase the radius in the X, and onto the mountain. Okay, so now we have a completely different source, and let's add a switch node and connect it here, and onto the switch we can change the switch. Okay, so let's add a simple expression to animate the input selector. So in here let's add a $F, which means the current frame number. Okay, so we say if the current frame number is less than 12. Okay, so less than 12 we have the input 1 selected. Okay, so here as you can see we are at the first 12 frame we are using this source, and then after the frame number 12 we are changing this to this source. Okay, and you can also reverse that by reversing this condition. So let's change this to greater than. Okay, so now we will have a reverse source, and first we are using this source and then we are using the second. And let's go back onto the Pyro solver and hit play. Here as you can see our second source is not being imported. So go back, and in here let's increase the frame range to 24, and let's increase the cycle length to 24 as well, and go back and hit play. Now here as you can see now we have a looping fire, so we are changing the source. Okay, and you can also uncheck the cycle length to disable the looping. Okay, so now we don't have the looping, and after the 24 frame we are not looping, but our source is gone. Okay, so that's basically how you can work with the OpenCL solve sourcing. So if I change this back to sparse and go into the sourcing, and let's uncheck the limit source range. Okay, so here we can enable the limit source on and off. So if I change this to minimal OpenCL, now we can't uncheck this limit source range, so the limitation will be applied. Okay, if you are working with the minimal OpenCL solve. So let's change this back to the sparse one, and let's not use our second source. So let's use the first source into the Pyro solver. So let's go back onto the sourcing. The limit source is checked on, so let's uncheck that. Okay, because I changed this to minimal OpenCL, so this gets checked on. So let's collapse that, and onto the fields let's uncheck the emit from flame, so we are not emitting the smoke from our flames. Okay, so basically we have fire. And let's also adjust the flame lifespan. Let's change this to 1 and check. Okay, the flame height is looking good, and now our turbulence is not working. So if we go into the shape tab, and here as you can see we are using the control field named density. So because we are not emitting the smoke and the density field is 0, that is why our turbulence is not working. So let's say even if I change the turbulence scale to 500, here as you can see the turbulence have no effect. Okay, to add the turbulence let's uncheck the use control field. Okay, and now let's change this back to 5. and now we have the turbulence working. Let's change the swirl size a bit. Let's change this to 2 to create a large scale swirl. Okay. Let's lower the turbulence down to 2 as well. So right now the turbulence is a little too intense. And here we have the option for enabling the viscosity. So let's enable that to create a more viscous flames. So let's add the viscosity to 0.2. And here, as you can see, now we have these smoother flames. Okay. And also let's go back onto the sphere. Let's increase the sphere size to 1 by 1. Right now our source is too small. And now let's hit play. And here, as you can see, now we have a lot more resolution as well, because we have increased the size of our geometry and we are using a smaller voxel size. Okay, so let's go on to the output. Let's write out our far caches. Okay, so let's go into the output and let's uncheck the CD and the velocity. Okay, and check this convert to VDB and use the 16-bit floats. Okay, and here, as you can see, when I click the convert to VDB, our fire is gone. So let's enable the flame density field. Okay, so it means that because we don't have the density, we are not emitting smoke from our flames, and for rendering we need the density information to tell the renderer where our volume is to render. Okay, so we need some amount of density to tell the render that where we have our volumes. Okay, so let's check the flame density and it is a very low value. Okay, so whenever you are working with only fire, you need to check this option on. Okay, so if we are emitting the flame or we have the density information, we don't need to click this option. For this simulation, let's enable that. Okay, and after that, let's lay down a file cache node. And in here, select your base name and the base folder, and let's change the overall frame range to 120. Okay, and let's, for the final render, I'm gonna change the voxel size to 0.03. Okay, so this voxel size give me enough resolution to render. Okay, so in here, press the save to disk option to write your caches. Okay, all done. So I have written out all the caches and here is our fire simulation. Okay, and now let's take a look at the volume deformation. Okay, so after when you have written out all your caches, you can use some post processing. Okay, for example, add the deformation onto your simulations. So if you right click, we have a node called volume deform node. So volume deform node is made out of two nodes. So here we have the first one, lattice from volume, and the volume deform node. Okay, and to set this node up, because here we have the caches which is pretty high res. Okay, so let's create a low res simulation for demonstration. Okay, for that let me copy this whole setup and let's delete this setup, we don't need that. And let's copy this setup and go back onto the first frame, and let's increase the voxel size to 0.1 and hit play. Okay, so here we have a low res simulation. Or let's change the simulation type to minimal OpenCL for faster, and let's hit play. And let's go onto the sourcing, onto the limit source. Let's check the cycle length to create a looping fire. Okay, so we have the basic looping fire simulation, and let's deform this. So here we have the lattice from volume, so let's connect that, and the volume to deform, so this is the same volume that I want to deform. And to add the deformation, so here we are generating the lattice, so which is basically scattering some points where our volume is. Okay, and in between you can add your deform node. For example, let's add a bend deformer. Let's connect it here. Set the display flag to bend, hover over to the viewport and press enter to have access to its manipulator. So let's bring up the bend parameters and let's change the capture direction in y-axis, and let's zero out the z. Okay, now we can bend in this direction. Let's increase the capture length and let's view it with our volume deform node. Okay, and here as you can see we are deforming our volume. So and go back, let's enable the twist to add a twist and add a twist. Okay, and let's see with our volume deform node. Okay, and at this point you can pretty much add any geometry deformation node. Okay, so for example let's add an attribute noise node and connect it here, and let's noise out our position. Okay, let's increase the amplitude, the element size, and let's view the result. Okay, so here as you can see we are adding a lot more detail. Okay, let's go back, let's delete the attribute noise and let's add a path deform node. Let's disable the bend for a moment and let's connect this, and it needs a path, so let's add a helix, connect it into the spine curve, and let's increase some parameter of the helix, decrease the turns and increase the radius. Okay, and now let's view this with our path deform. Maybe let's increase the radius a bit more, and let's go into the path deform. So path deform is capturing the deformation on the wrong axis, so let's go on to the capture and align and change the forward direction to y. Okay, because we want this direction to be captured and deform along curve. Okay, So now here, as you can see, we are deforming our volume with the curve. Okay, so that's the volume deform node to add the deformation. Now let's create spark for our fire. So for that we're gonna use the particle simulation. So here at the mountain sub, so here we have the source. So let's add a pop network. So let's connect that. We will talk more about the particles later in the course, and for creating these sparks, let's create a very basic particle simulation. So after when you have connected the source to the pop net, and if you hit play, here as you can see we are generating particles at the surface of our source. So let's add a point velocity node to give some velocity. Let's connect that, and let's set this to value and give him a positive y value, and also add a curl noise. And let's visualize our velocity by clicking on this V icon, and here we can adjust the scale and the swirl size. So these are our velocity vectors. Let's disable the velocity visualization and set the display flag to the pop net and hit play. And now here as you can see our particles are moving due to their initial velocity. So let's dive inside. So here we have the particle solver setup, and here we have the pop source node, and the emission type is set to scatter onto surface. Let's go into the birth tab, and here we have the constant activation set to 1, and we have the birth rate. So let's emit the particle first for only 3 frames. So for that let's add an expression onto the constant activation. So let's say $F. So if our current frame number is less than 3, so now we are emitting particle for first 3 frame, and here we have the life. So let's change this to 1 and add a variance of 1. Let's go back and hit play. So let's dive inside and to the attributes. Let's increase the velocity scale to add more speed to our particles. So let's increase the inherent velocity scale to 2. And hit play. So speed is looking good, and after we have generated our basic particles. So let's add a node called particle trail node. Let's connect that. So the particle trail node will generate these sparks by adding the trails to our particles. So here onto the color we can set the color. So let's collapse the color folder, and the color is set to uniform. So let's change this to sample ramp, and now we can use this ramp to color our particle trails. So click on this gear icon and choose the black to orange ramp. And here we can adjust the intensity. So let's add the intensity of 2. And let's go on to the shape tab. Here we have the frame duration. So let's increase the frame duration for longer sparks. And we have the length for the start and the end. So let's randomize this. So where it says set uniform, choose the set varying, and for the length end let's set this to varying to create a random length sparks. Okay, and onto the split, we can enable the splitting of our trail, so let's enable that. And here we have the split frame duration, so that's the length of the splitted trails. Okay, so let's increase that. And here, as you can see, we have some splitting visible. Okay, and you can increase the splits per point to add more splitting. Okay, and also let's go on to the shape tab and add the positional noise. Okay, so it will add a jitter to the overall motion. Okay, so if I disable the split for a moment for faster preview, here as you can see we have these trails undulating. So let's increase the element size. Okay, to create a more natural looking sparks. And let's go on to the split. Let's enable the split. Okay, so here onto the particle trail, onto the quick setup, let's click on this create material option to create the material. So it will create a material matte network. Here we have the principal shader. Okay, and here we have the material node for assigning the material. So by clicking this option, it creates the material as well as assign the material to our particle trails. Okay, so let's add an merge to view our particle trails with our fire. Okay, and here as you can see our trails are starting when our fire simulation is rising. So let's add a time shift to offset the timing of our particle trails. First let's create a file cache node to write our particle trails to disk. Okay, after the particle trail sub, let's add a file cache node and let's call this one spark. Okay, and let's choose the location. Let me delete the $heap name variable. So we are using the spark only the current node name. Okay, and here we are storing this to Ixeo, so let's change that. Okay, and press the save to disk option to write your caches. Okay, all done. So here we have the sparks written out to disk, and after that let's add a time shift node and connect it here. So here onto the time shift we have the method set to by frame, and onto the frame we have an $f expression. Here onto the $f, let's add a minus 30 to minus the 30 frame to add a 30 frame offset. Okay, so now here as you can see after the 30 frame we have our sparks. Okay, so let's view this with our fire, or maybe let's start our spark from frame 15. So let's go into the time shift and add a minus 15. Okay, so after 15 we have these sparks. Okay, so in the next lesson let's render our fire. Okay, Now let's render our fire. So let's go into the out section. So this time we are going to use the mantra to render our fire as well as sparks. Okay, so here in the out, let's add a mantra wrap. Okay, so here we have the mantra node to set the render setting. Okay, and let's go into the object level and let's select the angle of our liking, and into the shelf, press and hold the control key and clicking on the camera button to create a camera. Let's select the camera tool and the lock button is on. And now let's position our camera. Let's unlock the camera and let's hide the shelf. And so because we are using the mantra node to render our fire, so which mean here we have the material applied. Okay, so here we are generating the material, the principal shader. We are using this material for the spark, and here onto the pyro solver node and onto the look tab, here we have the material. Okay, so this material is already assigned because the assign material option is checked on. Okay, so which mean mantra can use these settings to render our flames. Okay, and if you want to create the material, okay, so for example we have set these parameter when we are creating our fire simulation, and if I want to adjust these shader parameters, so these parameters won't work. So after when we have written out the simulation, after that you can add a pyro bake volume node, and let's connect that. And here onto the pyro bake volume we have the pyro shader assigned. Okay, so let's uncheck the smoke. We are not generating the smoke. So here onto the fire, let's enable the fire and reverse our fire ramp. Okay, and go into the bindings, and for the fire, here as you can see we are using the temperature field for fire. So let's use the flame field. Okay, and for coloring let's use the flame field here as well. Okay, and here onto the fire let's adjust the ramp and also decrease the fire intensity. Okay, so basically now we have the same shader. So let's set the display flag to the merge, and let's go to the render tab, and the camera is set to raw camera. Let's use our object level cam1, and the render node is set to mantra, and let's hit render. Okay, so here we have our fire, and the spark shader is not correct. So let's dive inside this material matnet. So here we have the shader for the sparks. So here we are using the point color and we are multiplying this with this color, so 0.2. So let's change this to white, which means 1. Okay, so now we are using the same value from our SOP level. Okay, here onto the spark trail, onto the look, this intensity. Okay, so here we have the sparks, and let's go into the pyro bake volume and let's adjust the fire intensity. Let's lower the intensity, and also let's adjust the ramp to cut off all of our high intensity flame values. Okay, to create a more transparent flames. And let's also adjust the fire intensity a bit. Okay, so now let me stop the interactive renderer and go back here onto the onto the mentor node. Let's change the valid frame range to render frame range, and here onto the rendering, the render engine is set to ray traced. Let's change this to physically based rendering, and let's go back onto the render view and see with our changes. Let me stop the interactive renderer, and here you can adjust the pixel samples. So if you are experiencing noise, you can adjust the pixel sample to remove the noise. Okay, and go into the images tab, and here we have the output picture option to writing the EXR sequences. Okay, so let's change the location where you want to render your EXR sequences. Okay, so here I have changed the output picture location into my D drive, and the $F expression is necessary so that we don't overwrite the previous render sequence. Okay, and after .exr for the XR sequences, and press render to disk option to render out your sequences. Okay, and if you want to render your fire in Karma, so here onto the output you can add a Karma ROP. Okay, so if you dive inside, so here onto the Karma ROP, here as you can see we have the LOPNet, and in here so we are importing our scene inside of LOPS Solaris. Okay, and here we have the Karma node to render out our scene. Okay, so let's delete the Karma ROP from here, and let's set up our Karma ROP on our own. So let's go into the stage, and first let's go back onto the object level and create the different output nulls. Okay, for referencing. So in here let's add a null, and let's call this one fire, and let's duplicate this null, and this one to be our sparks. Now let's go into the state context and use the SOP import, and in here let's import our fire, and let's duplicate this node again, and let's import our sparks. Okay, and let's add an merge node. Let's rename this to fire, and this one spark, and after that let's add a material library. So you need to assign the material on this level. Okay, so the SOP level materials won't work. So let's dive inside. In here let's add a principal shader for our sparks. Let's call this one sparks, and use point color is checked on. Let's change the base color to white. Okay, so now we are using the point color for rendering. And for the fire let's add a pyro shader, and in here at the fire let's enable the fire, and let's copy the settings from our original shader, this one. So let's copy this ramp. Okay, copy parameter onto the stage, say paste relative reference. Okay, or you can adjust it from here. Let's adjust the intensity to 50, and also onto the bindings, onto the fire, let's use our flame field. Okay, so this is the field that we are going to render as a fire. Okay, and onto the material library, click on auto fill material to fill the materials, and onto the assign to geometry, let's enable that. And for the sparks, let's select the spark node. So the geometry path, you can add a name. So here, as you can see, we have the spark. And for the fire, let's add our fire into our geometry path. Okay, and after that, let's add a karma node, and let's change the renderer to karma. Okay, so here, as you can see, we are rendering with the karma. Let's change the background by clicking on this eye icon and go into the background, change this to dark. Okay, and let's disable the grid. Okay, so that's how you can set up your renderer, both using the karma and the mantra. Okay, so here we have the resolution, and the output picture, choose the location, and onto the USD render op, select the frame range, render specific frame range to render out your whole sequences. Okay, and press render to disk option to render your sequences. Okay, all done. So the rendering has been finished. So here is the end results. Okay, so here we have the flames rendered and the sparks, and the flames are looking very nice, these transparent flames. Okay, and if I go back into the stage context, and here, as you can see, when we are importing our fire, I can't see my fire in the viewport, and that is because into the object level, so we are using the pyro bake volume to assign the shader. Okay, so if you are rendering in the Solaris, we need to disconnect that. Okay, because we are assigning the shader in the Solaris. So now I have disconnected the pyro bake volume. Okay, so now if I go back onto the stage context, and here, as you can see, I have my flame volume displayed correctly inside of Solaris. Okay, so here is our fire rendered. Okay, now let's create explosion. So let's create a source for our explosion. So let's create a geometry node, and in here let's add a node pyro burst source. So for the source of our explosion, we're gonna use the pyro burst source. So let's open up the parameter for the pyro burst source, and here we have the burst type is set to explosion. So if I bring up my play bar, enable the real-time playback, and hit play, and here, as you can see, we have an explosive looking source, and you can change this to muzzle flash. Okay, so now we have a little bit more pointier source, and you can change the direction. So here the direction is set to Y, so let's zero it out and set the X to 1. Okay, so now we have a source on the side, so let's change this back to 1 in the Y, and also we have the burst type set to shockwave to create a ground shockwave, and also we have the option to set the blast rings. Okay, so these are the explosion blast rings. Okay, so let's change this to explosion, and here we have the shape offset, so that's the noise offset, and also we can set the initial size, and we have the spreading to control the trail spreading, and we have the option for roundness, so we can create a more round trails or a more pointier trails. Okay, and here you can adjust the number of trailings, create more or less trails, and here we have the trail separation. This will add more particles in our trail, and we have the trail length. We can create more bigger trails by adjusting the trail length, and also we have the trailing thickness. And here onto the burst animation, we have the option to set the start frame. So for example, if you want your source to start on the frame 10, so if I change the start frame to 10, now at the 10 frame our source will start at particle. Okay, and here we have the frame duration. Let's change this to 1. So that's the frame duration for how long you want your trailing to live. Okay, and also we have the overall expansion. So here you can control the expansion of your trailing as well as the directional transition. And onto the burst component, we have the attributes to set. So here onto the pyro source, we are creating an intensity attribute and a temperature and a burn. Okay, you can add more sources by clicking on this plus button, and here check the create source, and here you can select the attribute that you want to create. Okay, so let's remove that. And on the output attribute, we have the option to output some attribute. For example, the source attribute, the source name, and the particle scale. We have the velocity, and we can also add the velocity noise. Okay, so if I enable my velocity visualization, and here as you can see, these are the velocity without the noise, and here we're adding the noise to our velocities. I can adjust the amplitude and the swirl size. Let's disable the velocity visualization, and up here we have some quick setups. So if you click that, here we have the option to add a source volume. So if I click that, it will add a volume rasterize node as well as fill all of the attributes that we have created with the pyro burst source. Okay, so now it will filling these attributes automatically. So if I go back and onto the burst component, if I add another attribute and create the source, and let's say add a divergence, and now if I go into the volume rasterize, here as you can see the divergence has been added automatically. I can also remove the attributes. Let's remove the divergence and the burn. So now we have the density and temperature. Okay, and onto the pyro burst source, here we have the option to set up the pyro simulation. So now it will add a volume rasterize node, add the attributes, as well as set up the pyro solver for simulation. It will also import all of these sourcing fields. Okay, so let's remove that. So in the input we can define the points. So for example, if I add a line, so here onto the line we have 2 points. Let's increase the length of our line, and now if I connect that, now here as you can see Our pyro burst source is utilizing these input points to generate these sources. I can increase the number of points for more of these particle trailings. Okay, let's change our direction. Let's set this to x1 and 0 out the y component. Okay, and onto the pyro burst source, let's increase the initial size to create larger size of our source. Okay, here onto the pyro burst source, let's go into the burst animation, and here we have the start frame. So right now it is set to uniform, so we can click on this randomize button, so it will add an attribute adjust node. Okay, so here onto the attribute adjust node, we are adjusting the attribute name start frame, and here now it is using the attribute to set the start frame. Okay, and here onto the attribute adjust, we have the pattern set to random, and the range is minimum plus the range length. So let's increase the range length as well as the minimum. Let's keep the minimum at 1. Okay, so now we have randomly generated burst shapes. Okay, so onto the pyro burst source, let's add a source volume. So now we are adding the density, temperature as well as the velocity. So let's go back onto the burst component. Let's add another attribute and create a burn field, and also let's add a divergence for the expansion, and also click on the scale along trailing. Okay, so this will fade out our volume, and onto the output attribute, let's add a velocity noise. Okay, and after that let's add pyro solver and connect that, and onto the pyro solver, onto the sourcing, so we have the density, temperature, burn and the velocity. Let's add the divergence, so let's add that another source and go down. Let's add the divergence to our divergence simulation field. Okay, and let's hit play. So right now the simulation is slow because the voxel size is set to 0.1, so which is a much high res simulation. So because we are using a large scale source. Okay, so let's change this to 0.5 for faster preview and hit play. Okay, so the simulation is still running slow. So here onto the volume rasterize attribute, we are using a very small voxel size, so the sourcing is slow. So let's copy this parameter and link this to our volume rasterize attribute. Okay, so now let's hit play. Okay, so here as you can see, now we have a much faster simulation. So in the next lesson, let's adjust the settings in our pyro solver to create an explosion. Okay,